Check one, check one, check. Hello, Pak Isbran. Can you hear me, Pak?
Hi, good morning. Yeah, I can hear you loud and clear.
Halo, selamat siang Pak Ilham. Boleh cek audio udah Pak sama videonya Pak. Speaker ke TV dah.
Halo semua, selamat siang.
Ya, selamat siang Pak.
Sedang menyelesaikan lunch. Nggak apa-apa. Lanjut.
Oke Pak.
Jelas ya suara.
Pak Ilham boleh di mute lagi. Di unmute. Ya, oke.
Jelas suara saya ya.
Jelas Pak.
Sementara saya boleh mute dulu.
Boleh Pak, boleh.
Terima kasih.
Sama Pak.
Cek, apakah suara saya terdengar?
Iya Mbak, terdengar suaranya. Jelas.
Oke, nggak double ya sama suara di sana.
Enggak Mbak.
Terima kasih.
Hello, Pak Zelensky. Can you hear me and can you see me? Can still mute, but can you please unmute your microphone or check your audio and then video?
Okay. Now it's
Yes, but I
Yeah.
can hear you and see you clearly. Pak.
can you hear me now?
Yes, but I can hear you clearly, but and then I can see you clearly.
Okay, so technically it's perfect.
Yes, I'm Mikwan. I am IT from World Bank. I'm operator in webinar Zoom. Thank you, Pak, for the testing. Thank you.
So the testing is completed, yes?
Yes, Pak. I think your audio is good. Video is good.
Okay, so I can finish testing and come back when the
Yes.
webinar will start. Yes.
Yes, Pak. Yes, Pak.
Thank you very much. And what about the presentation? The presentation I will present from my computer by sharing screen.
From here, Pak. From here.
Hello, Mr. Janus. How are you?
Well, fine, and you?
Glad to see you. Very nice meeting you finally in person, virtually. Yes. So for the presentation, we can share the screen. We can help you to share the screen, so you don't need to worry. You can focus on the presentation.
Yes. So I will use my presentation on my computer because, or you will present. You will do the. You will show the presentation, but how? Which choice? Which option is in use?
We can share the screen, Pak Janus, because we already received your presentation. So there is a team here ready set to share the screen, and the presentation has been made available for sharing. So that is
okay. So how can I change slides if you will share my presentation with participants?
Okay, so you can just say next, and then the lady
okay. So
we'll continue to the next slide.
okay, now it's clear. You know, it's always good to know. Perfect. So I have no questions. Thank you very much for this testing connection.
Thank you so much, Mr. Janus. Yes, we're glad to receive you here, and all the best for the presentation today.
Okay, thank you.
Thank you.
See you later.
Thank you. See you later. And good afternoon, Dr. Leite Ribeiro, Dr. Marcelo. Very nice meeting you.
Good afternoon, good morning. Very nice to meet you too, finally, after all these exchanges.
Yes, glad to see you in person. We have received your presentation, so we will be able to share this presentation, share the screen of the presentation for you, so you don't need to worry about that, and you just say next, and then she will continue.
Perfect, very good. Yeah. I just see that my background here is in mirror. I think I have to change that, right?
Okay, so there is an updated background provided in the link that we shared with you earlier. So if you are interested to use the latest link, so you can download it at the same link that we have provided to you. So there has been a change because we cannot see the name of the webinar on top of our head.
I see.
Yeah.
Okay. No problem. So I'm going to change that.
Okay.
And so I think from
the audio perspective is okay, so we can hear you clearly. So that's great. Yeah.
Very good. Yeah, I'm at home now, but I'm going because it's still early in the morning here. I'm going to the office. So the webinar will start in 40 minutes around, right?
Yes, about 40 minutes from now. So
Okay.
if you want to reconnect again later during your session, that's fine because
Yeah.
I believe it's early morning for you there. So thank you
Yeah,
for
no,
joining.
but because I'm just going to, I'm at home now, so I'm going to the office. It's better there because I have another meeting, as I told you.
Yeah,
At,
that's true.
Your time, it will be at 9 here. At
Yeah.
3 your time.
Three, yeah, okay.
Yeah,
that's
so I
fine.
have to leave, unfortunately.
Yeah, that's fine. So we maybe just if you, I think there's a little spare of time just before 3. So maybe if there are people who have questions, if you wish, you can respond to them. But if not,
Perfect.
yeah, in the chat box. But otherwise, it's fine. I think the time will be sufficient.
So
We
questions will be on the chat, right?
Yeah, question will be provided on the chat, and then some of the selected questions will be delivered by the moderator. So if you stay until 14:40, 2:40 p.m., then you can join the Q&A session. Otherwise, if you leave it earlier, then maybe you can respond to some of the questions through chat box. If
Okay.
that's fine
To
with
me, I have to see, because I
Yeah.
say at this meeting, so I will see. But in any case, if I leave, I will just send a message by to the chat that I'm leaving. So I'm not okay.
Yeah, that's
Very
fine.
good.
Yeah, very good.
Okay, so I
Thank you
will
so much.
reconnect in a couple of minutes.
Yes, looking forward to see you again later. Yeah,
Great.
thank you,
Thank
Dr.
you.
Lee. Thank you.
Bye.
Good afternoon, Tara. How are you?
Hi, Pa. Good. I'm
Okay.
still,
Are you in the office?
Yes, we are in the office together, but so I'm in different room from the other IT
Marina.
team. So that's why I'm trying to
Connect.
prepare the link for the materials. I mean, there is already a link, but just to make
Okay.
a nice link for the for the people. Okay. So, okay.
All right. So this is the link to the webinar itself, right? You were talking about another link. a few
Yeah,
minutes
another
ago.
link to just do the materials. Yeah, just for the
Yeah.
materials so that people, because people are already asking me about where is the webinar background, etc. So
I see. Okay.
they are very excited. That's
Apparently,
good.
yeah.
We have
Good,
already 560 people.
Oh, serious?
This is
Oh,
and
wow.
even this is a closed, right? I mean, this is a closed webinar. We
Yeah,
don't
yeah.
share to so many social media yet, but still there are many people interested.
Great.
So that's good.
Excellent. Yeah. Happy to hear.
Yes. So I will share the link here. I will just mention.
So where are you now, Vice Brand?
I'm in DC.
Oh, DC already.
Oh,
Yeah.
thanks. Kalau aku mau share ke everyone.
Mas Empanas.
So so the link is provided here.
Baru
So
ada
you
Mas
can
Empanas
check
soalnya.
the link and also the webinar.
Okay. Yeah.
Karena belum ada partisipan kan.
Oh yeah. So this is the webinar background. If
Right.
you want to use the same one. This is your house, Pak Isran? You are in your house?
Yeah.
Ah, okay. It looks different from the previous one.
Really? Okay.
There's something
That's same
new.
house.
You have
Same
to
house.
again.
Okay. Yeah.
Yeah.
Oh yeah, Pak, for the closing remark, will you be able to provide some closing remark? Maybe just
Yeah, sure. Yeah,
before-
pleasure. Yeah.
Yes, I think it would be good to share your closing remark, because then we can bring it to the attention that this is important and
Yeah.
we want to take it forward. Yeah.
Yeah, exactly. Yeah.
Okay, Pak. I see that Paulo is here, and Pak Jarod. Welcome to the webinar. I hope you can hear us.
Good morning. Can you hear me?
Good morning, Mr. Paulo.
I will just receive your email. I just wake up because it's quite early in Italy, and I'm
Yes,
sending the
right.
material in 2 minutes. It's okay.
Okay.
It's my PowerPoint.
All right. Okay. Yeah, we were looking
Oh,
forward
oh,
to receive it.
I would like to ask if I can anyway share my screen or not during the presentation. That could be easier for me to present.
If that will be easier for you, that's fine, Paulo.
Yeah,
But maybe
I think that's better.
if we can test it now quickly here, just to make sure
Yeah.
that it's working. Yeah.
I can do now.
Okay, just very briefly, that's fine.
Yeah.
Okay. Thank you.
Let's see. Can you see the screen?
Sounds good, but yes, we can see the screens. Excellent.
Perfect. I'm sorry, but I just looked right now at the base, the layout. I don't think I'm able in time to switch to the format. Maybe the first slide. I
that's
will
fine.
try.
You mean
to
the
do.
format of the presentation? No, there's no template for the PPT, so you can share. as you
Okay.
wish.
Okay.
So no
Perfect.
problem.
Good.
I think what we meant is just the background of the webinar screen. So
Okay.
if you want, you can download from the link that we provided earlier.
Okay.
So
I will.
if you feel
I will send
comfortable-
this one.
Yeah. Okay.
This is feasible.
Yes.
Thank
okay.
you very much.
Thank you very much. Yes, and maybe Paulo, in Indonesia, actually, there's a lot of earthquakes. So this is something that actually the director was very interested to know, because they want to know how to actually handle or manage monitoring for earthquakes. So I think your presentation will be very exciting for them. And we have already like around 500 participants that would like to hear
Wow. It's a
presentation.
huge number.
Yeah. I have not
Okay.
to put pressure, but we're happy to.
No. I will try to do my best.
Yes, and Pa Isran is here also, our testing leader of the Indonesia.
Good morning, Mr. Masanti. Pleasure meeting you.
Good morning. Nice
Pleasure
to meet you.
meeting you. Yeah.
Yeah, it's my pleasure.
Okay, thank you.
That's the link for the presentation as well, is right?
Yes, for the presentation.
I can
and
stay
for-
here. Okay,
Yeah. Yes.
good.
Yeah. So if you can
Okay.
share the presentation with us, then we.
Yeah. I'm in a minute. I will. I'm sharing with you.
Okay. Thank you so much, Mr. Paulo. Yeah.
You're welcome.
Okay, we also see Pak Jarod here earlier. Maybe it's
I
not.
think he may have left. I don't see him anymore.
He may have left. Okay. Yeah. So
Can you check my background, Tara? Because I
Ah,
see
yeah,
it in
yeah.
the mirror. Do you see it correct or
It's correct. It's correct. Yeah.
Okay, all right.
It's good.
Okay.
It's good. Yeah. 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 I made this myself. This very rushed. Yeah. Oh yeah, Pak. So the DG is like Pak Ilham said before. So the DG is currently in another meeting with the MOF. Quite sudden, yeah, Pak Ilham. So it's
Yeah, actually, he supposed to meet with Minister of Finance on 9 this morning, so he was ready for 1 o'clock. But unfortunately, those meeting with Minister of Finance is postponed to the afternoon, so that's why he need to be there. Yeah,
yeah.
but for backup, he said that Erlangga will be ready for representing him.
Yeah.
Okay.
Yeah, and I have communicated with Pak Erlangga, so I request Pak Edwin to assist him on the preparation of his welcoming remarks.
Good. Good.
Thank you, Pak.
En selamat siang Pak Ilham. Apa kabar?
Selamat siang, Bapak. Selamat malam, Bapak ya.
Ya.
Ya, baik Bapak. Antusias Pak, waiting for this very interesting.
Yeah, it's great that we have so many people. Really
500.
exciting. Yeah, excellent.
Quite a hard task for the management of this question and answer later on. Maybe there are a lot of questions.
Oh,
Yeah, on how to pick to select a good question or something like that.
Yeah. No, I think we're in good shape. Thanks for all the hard work.
Okay, Pak. Thank you. Sama-sama.
Thank you, Pak.
Background saya udah betul ya, Tara ya?
Cakep, Pak. Betul, Pak.
Tapi kalau mau update namanya, caranya gimana ya? Saya klik yang poin 3 poin itu, 3 titik itu ya?
Untuk apa, Pak? Update nama?
Ya.
Untuk update nama, iya di 3 titik. Mana ya? Kayaknya di sebelah kanan. Mana ya? Enggak ada ya. Saya kurang tahu Pak ya. Kayaknya ini karena kita panelis ya,
Pak Ilham diklik nama Pak Ilham tuh kan ada titik-titik 3 tuh Pak.
Ya.
Diklik nanti di situ ada rename nggak Pak?
Nggak ada ini.
Ada nama saya. Mau diganti apa Pak? Mau diganti nama lengkap Pak?
Ya Ilham Abla aja.
Oke.
Nanti banyak orang Ilham sekarang.
Sudah Pak, sudah saya ganti Pak.
Ya gitu. Ya, thank you Pak Ikhwan.
Sama-sama Pak.
Hello, Professor Koike. Very glad to see you.
This is Toshio Koike. Miss Tarasinta,
Hello, Professor
Oh.
Koike. Very nice to meet you.
nice to meet you. This is just a test connection, and
Yes.
I will join the
Afternoon session.
the second session today. Is it okay?
Yeah, that's fine, Mr. Koike.
Okay.
Maybe you are able to connect your camera as well. Your audio is perfect.
Yeah, I will check the my slide, the feature I would use in my talk.
Mm.
Is it okay now?
Yeah, it's okay, but yeah. And now
Just one.
for later in the afternoon, later on the second session,
Yes, yes.
your presentation can be shared through our team here.
No. I want to, as I wrote, I want to operate
yeah, you want to
myself through the. Can I check my screen
Yeah.
sharing now?
Sure. You can
Okay.
check your sharing screen now if it's
Thank
ready.
you.
Thank you.
And can you see my screen?
We can see your screen. Yes, sir. Yeah. This is this looks good.
It's okay.
Okay, yeah. Perfect.
Okay, thank you.
Professor.
So I have a meeting in the up to the 4 p.m.
Okay.
Of Japan. In Indonesia. I'm not sure. Anyway,
Okay.
just before the afternoon session, start of the afternoon session, I will join. Okay.
Okay, sir. Yeah. So the afternoon session here would be at 3:15, and
Yes.
maybe Japanese time would be
5:15. Yes.
Okay,
I
yeah.
will join around 5. Okay.
Okay, yeah, sounds great. Thank you so much, Professor Koike, for connecting shortly today. Sorry for the for the
It is very good. Okay.
Yeah.
See you later.
Thank you. See you later, Mr. Koike.
Bye.
Yeah, bye. Very nice to meet you. Selamat siang, Bapak Jarod. Semoga Bapak bisa mendengar suara kami. Terima kasih telah bergabung. Sebelum acara hari ini, kita akan mencoba melakukan testing audio, Pak. Testing audio dan kamera untuk memastikan bahwa suara dapat didengar oleh para peserta. Mungkin sekiranya kita bisa testing sebentar, mungkin oleh tim teknis Bapak tidak apa-apa. Mbak Nina, boleh dicek untuk interpretasi? Oke, boleh saya tes dulu interpreternya. Ladies and gentlemen, could you hear me? Could you hear me in bahasa?
Yeah, we hear you, Tara.
Ya, Pak. Interpreternya sudah aman? Apakah Pak Miki sudah hadir?
Send the English channel.
Gimana?
Tara sudah join, Tara.
Iya, maksudnya sudah bisa. Kita tes dulu, sudah bisa. Apakah sudah bisa didengar dalam bahasa Inggris? Cek. Mbak Nina coba dengar di dalam mode bahasa Inggris.
Yes, Mbak, English. I can hear you, Mbak.
Oke, sounds good. Thank you. Oke, mungkin 5 menit lagi kita akan persiapan untuk buka channel ya. Selamat siang Pak Edwin.
Selamat siang, Mbak.
Ada Pak Faris juga di sini yang akan membantu untuk memandu Pak Irfan ya.
Selamat siang, Pak Edwin.
Selamat siang, Pak Isbran.
How are you?
I'm fine. How about France?
Everything okay here?
Okay, where are you, Pak Isbran? Still in Washington?
I'm at home in Washington, yeah.
Okay.
Pak Edwin, untuk webinar background bisa di-download di link material yang baru saja saya kirim di chat box. Silahkan nanti kalau untuk mengganti webinar. Terima kasih. Oh ya Pak Edwin, kami masih belum menerima paparan dari Pak Neil. Kalau misalkan nanti ada WA beliau mungkin bisa diingatkan. Beliau janji akan kirim nanti siang mungkin.
Oke.
Masih proses ya. Tapi karena di sesi kedua sih sebetulnya masih aman sih.
Backgroundnya di mana ya, Mbak?
Ada di yang nomor 2, tulisannya webinar background. Sudah ketemu, Pak?
Belum.
Belum ya? Ini nih saya share juga di sini aja ya. Pak Ikwan, apa kita sudah bisa lihat ada berapa jumlah peserta yang sudah waiting di waiting room?
Di attendance masih kosong ya, Maya?
Di attendance masih kosong ya? Belum ya? Belum connect?
Iya.
Jadi kalau gitu.
Mbak Tara. Halo Mbak Tara.
Halo, iya Mbak Retno.
Iya Mbak Tara, untuk Mas Sandi sama Mas Rido ini kan nggak dapat email dari Mbak Nina sebagai panelis, jadi pakai akun saya.
Oh, oke.
Ya.
Oh, pakai
Terus
akun.
belum bisa di rename, jadi masih double.
Oh, iya. Ini terjadi sebelumnya seperti yang kita pernah lakukan dulu. Atau di masing-masing sudah. Sudah dikirim ke masing-masing katanya, tetapi mungkin bisa dikirim, bisa kadang masuk di spam, masuk ke spam kadang, mungkin bisa dicek kembali. Bentar,
Jangan dulu ya.
bentar, aku tadi makanya nanya dulu sama Pak Ikwan sudah ada berapa orang yang itu.
Oke,
Kita cek dulu ya. Pak Ikwan, mungkin boleh kita buka aja untuk peserta supaya kita tahu ada berapa jumlah peserta yang sudah masuk. Pak Ikwan, mungkin bisa kita buka. Oh, mungkin sebelum itu saya ingin memastikan Pak Edwin, apakah Pak Jarod akan bergabung ya sebagai keynote speech atau berarti Pak Erlangga kan masih menunggu?
Halo siang Mbak Tara.
Oh, selamat siang.
Ini Miki.
Oh iya Pak Miki, selamat siang Pak.
Sorry baru join, agak mepet.
Selamat datang Bapak Ibu peserta acara webinar DEM Safety from Space. Kita akan menunggu sebentar lagi untuk memulai acara. Sambil menunggu akan ada webinar background yang dapat digunakan. Bapak Ibu dapat mendownload webinar background sesuai yang telah disampaikan melalui chat box. Terima kasih. Selamat datang Bapak Ibu yang baru saja hadir di acara webinar DEM Safety from Space. Kita akan tunggu sebentar lagi untuk memulai acara.
Pak Erlangga sudah ada tuh.
Oh iya, baik. Selamat datang Pak Erlangga. Terima kasih sudah bergabung.
Bapaknya masih mute.
Selamat siang Pak Ilham, Mbak Tara.
Selamat siang Pak Direktur. Sehat Pak?
Alhamdulillah sehat.
Alhamdulillah. Terima kasih Pak.
Mana kok videonya Pak Ilham nggak kelihatan?
Pak Ilham masih bersembunyi nih Pak, belum kelihatan. Terima kasih Pak Erlangga sudah menyempatkan waktunya.
Selamat pagi, selamat siang Pak Erlangga.
Siang Pak Isbran. Pak, saya backgroundnya saya pakai ini dulu nggak apa-apa ya? Background.
Oh ya, tidak apa-apa Pak Erlangga.
Ya.
Masih seputar bendungan juga Pak sama temanya.
Oh, diganti ya?
Izin ini Pak Dirjen sedang masih ada acara dengan Bu Menteri Keuangan. Jadi beliau menugaskan saya ini.
Oh ya, baik Pak Erlangga. Terima kasih banyak sudah bersedia hadir untuk mewakili Pak Dirjen. Kita tunggu sebentar lagi ya Pak untuk memastikan peserta sudah banyak yang join, kemudian kita akan segera mulai. Untuk sekedar informasi kepada teman-teman peserta, di sini akan ada interpretation channel yang dapat digunakan untuk switch bahasa dari bahasa Indonesia ke bahasa Inggris dan juga kebalikannya. Jadi silakan nanti jika Bapak Ibu ingin menggunakan interpretation channel yang telah disediakan untuk dapat menikmati acara webinar dari bahasa Indonesia maupun bahasa Inggris. Baik, kelihatannya peserta sudah mencapai 150. Alhamdulillah, terima kasih Bapak Ibu telah bersedia bergabung di acara webinar kita kali ini. Kami harap nanti semakin banyak teman-teman yang bergabung sehingga akan semakin banyak manfaat tentunya dari kegiatan webinar ini untuk teman-teman terutama di Kementerian PUPR, Kementerian Bappenas dan juga institusi lainnya. Baik, mungkin kami akan mulai acara sesi webinar kita kali ini. Sebelumnya kami ucapkan Assalamualaikum warahmatullahi wabarakatuh. Selamat siang, salam sejahtera bagi kita semua. Om Swastiastu, Namo Buddhaya, salam kebajikan. Bapak Ibu peserta yang telah menghadiri acara webinar ini, jadi acara ini merupakan wujud kerjasama antara Bank Dunia bersama dengan Kementerian PUPR dan juga Bappenas yang bertujuan untuk mendapatkan pembelajaran dari pengalaman dan pengetahuan internasional mengenai pemanfaatan teknologi modern dalam rangka meningkatkan keamanan serta operasi dan pemeliharaan bendungan di Indonesia. Sebelumnya, Bank Dunia telah menyelenggarakan 7 webinar series yang bertemakan Indonesia's Water, Too Much, Too Little, Too Dirty bersama dengan Bappenas yang telah berhasil mengundang banyak sekali peserta dari berbagai pemangku kepentingan dan juga dari berbagai macam background profesi dan pendidikan, serta speaker-speaker internasional. Nah, pada kesempatan webinar kali ini, kita bersama dengan Bappenas dan Kementerian PUPR akan membawakan topik yang sedikit lebih teknis, tetapi juga aplikatif, dengan speaker-speaker yang tentunya ahli di bidangnya, yang tidak kalah inspirasional. Nah, izinkan kami untuk menyampaikan salam hormat dan ucapan terima kasih kepada yang pertama Bapak Jarod Widyoko selaku Direktur Jenderal Sumber Daya Air Kementerian Pekerjaan Umum dan Perumahan Rakyat yang rencananya awalnya akan menghadiri acara webinar ini. Dan kami ucapkan juga terima kasih kepada perwakilan dari beliau yaitu Bapak Airlangga Marjono selaku Direktur Bendungan dan Danau di Kementerian PUPR yang telah menyempatkan waktunya untuk hadir bersama kita untuk memberikan welcoming remarks di acara webinar ini. Yang kedua, kami juga ingin menyambut Bapak Muhammad Irfan Saleh selaku Direktur Sumber Daya Air Kedeputian Sarana dan Prasarana Badan Perencanaan Pembangunan Nasional Bappenas yang akan menjadi moderator dari sesi pertama di acara webinar ini. Kami juga ingin menyambut Bapak Edwin Alexander selaku perwakilan dari Direktorat Bina OP dan Pemeliharaan, Operasi dan Pemeliharaan PUPR yang mewakili Bapak Direktur Bina OP untuk menjadi moderator di sesi kedua webinar ini. Kami ucapkan selamat datang dan terima kasih kepada para narasumber, baik nasional maupun internasional, yang telah hadir bersama kita dari berbagai penjuru dunia untuk berbagi ilmu dan pengalaman bersama kita. Nah, webinar ini akan berlangsung selama kurang lebih 4 jam, dari pukul 1 siang hingga pukul 5 sore nanti, dengan diselingi oleh afternoon break setelah sesi pertama. Oleh karena itu, kami persilakan Bapak Ibu untuk duduk dengan nyaman dan rileks untuk dapat menikmati acara webinar ini. Mungkin saya akan menjelaskan sedikit mengenai rundown acara. Dalam webinar ini akan dibahas 2 sesi menarik. Masing-masing sesi akan dipandu oleh moderator, dan di akhir paparan dari setiap sesi akan ada sesi tanya-jawab. Peserta dapat menyampaikan pertanyaan nantinya kepada para narasumber melalui chat box yang akan dipilih dan disampaikan oleh moderator kepada narasumber. Di akhir dari sesi pertama akan ada interactive session, yaitu kuis berhadiah mengenai pengetahuan seputar bendungan. Untuk tahu apa hadiahnya, mari kita stay tune hingga akhir acara webinar ini. Perlu kami ingatkan kembali bagi Bapak Ibu yang baru bergabung di dalam Zoom maupun YouTube link kami, bahwa panitia menyediakan fasilitas interpretasi, sehingga Bapak Ibu dapat mengaktifkannya dengan memilih tombol interpreter dan pilih bahasa yang Anda ingin dengarkan di bagian kanan bawah aplikasi Zoom Anda. Demi kelancaran acara, dimohon Bapak Ibu untuk dapat menonaktifkan mikrofon selama acara berlangsung, kecuali dipersilakan oleh moderator atau panitia. Sebelum acara, dimohon untuk para peserta dapat mute mikrofonnya, dan tentunya di sini ada juga sosial media dari Ditjen Sumber Daya Air di PUPR, yaitu di @pupr_SDA, dan ada juga sosial media Direktorat Sumber Daya Air Bappenas di @KMCDP Bappenas. Nah, Bapak Ibu, tidak berlama-lama, marilah kita mendengarkan welcoming remarks dari perwakilan Bapak Dirjen, yaitu Bapak Airlangga Marjono, selaku Direktur Bendungan dan Danau, Kementerian PUPR. Kepada yang terhormat Bapak Airlangga, kami persilakan.
Terima kasih, Mbak Tara. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Selamat siang dan salam sejahtera untuk kita semua. Pertama-tama kami sampaikan permohonan maaf Bapak Direktur Jenderal Sumber Daya Air, Bapak Insinyur Jarod Widyoko SP1, pada jam yang sama masih ada agenda dengan Ibu Menteri Keuangan, dan beliau menugaskan saya untuk menemani Bapak dan Ibu sekalian serta menyampaikan welcoming remarks dari beliau. Jadi perkenankan saya juga membacakan welcoming remarks beliau. To the honorable official from Bappenas, from World Bank, from Directorate General of Water Resources, from UNESCO, and from state-owned company, and also distinguished speaker and all participants. Ladies and gentlemen, firstly, allow me to give thanks to the Almighty God we can gather here on this day. It is of a great honor and pleasure for me to be among this distinguished audience this afternoon in the webinar Dam Safety from Space. I would like to welcome and express my appreciation to all participants for making the time to attend this particular webinar, and my appreciation as well to today's outstanding speakers who will share their knowledge and experiences that hopefully will let us learn through global experience and propose a program that will scale up the use of advanced technologies to improve dam safety, operation, and monitoring, most particularly in Indonesia. I would also like to thank our collaborative partner, Bappenas and the World Bank, for their efforts in organizing this excellent webinar, in hope to make a positive impact to the water resources, especially in dam safety management. Ladies and gentlemen, as population has rapidly grown in bigger numbers, the demand for water consumption is also increasing, where this could potentially be making the world in a vulnerable place when it comes to water resources. The turbulence of global economy and disasters have a critical connection related to water resources, not to mention the climate change issues. The threats of flood and drought are the reasons for country, especially Indonesia, to pursue the improvements of the function in dams or reservoirs. Dam is one of the solutions to resolve water crisis and climate change. Dams are built to provide water for human consumption, irrigation, electricity generation, and some other purposes. Over the decades, the construction of dams all across the world are rapidly increasing. Thus far in 2022, the operating dams in Indonesia are about 257 dams, where 215 of them are managed by government through Ministry of Public Works and Housing. The plan is until 2024, there will be 32 dam addition that is currently still a work in progress. So that the total targeted reservoir capacity from all dams in Indonesia on 2024 would be 17.63 billion meter cubic to accomplish the reservoir capacity of 668 meter cubic per capita per year. Indonesia potential dam development are quite promising to support its economic growth and the welfare of the people. To ensure the safety of the dams, rehabilitation and upgrades on the dam facilities and the improvement of the dam operation and safety management are indeed significant. Ladies and gentlemen, many dams in Indonesia are located in remote area where access is limited. Significant efforts are required in order to collect data regarding this dam, where some of the dates are sparse. However, this data play a significant role in the study National Integrated Water Information System that includes the accurate information of each dam, operation system, and safety status. In response to this situation, Indonesia is taking a massive step in investing the modernization of hydrological data monitoring and enhancement of analytical capacities in result of improved reservoir operation and dam safety. In these modern years, technologies are developed into a more advanced version time after time. One of the modernized technology that Directorate General of Water Resources are developing, including using radar monitoring system called Interferometric Synthetic Aperture Radar, or INSAR, to improve dam safety monitoring. This technology uses the principle of active remote sensing from Sentinel-1 satellite data to analyze its dam deformation continuously throughout the years. Henceforth, we would also be developing and collaborate another remote sensing technology to improve the dam safety monitoring system and would be implemented in each river basin organization. The combination of modern technologies, visual inspection, and in-person visit can be a revolution to the quality of dam safety that are affordable and provide reliable information for decision making. Distinguished participants, ladies and gentlemen, finally, on this very occasion, among these brilliant minds, with many of opportunity to learn and discuss through the advanced technologies, experience, and knowledges. Hopefully, as a result, not just having the answer to question we eagerly want to know, we can also propose a way to scale up the use of advanced technology to improve dam safety in Indonesia. Thank you. Demikian Bapak dan Ibu sekalian, welcome remarks dari Bapak Dirjen yang telah saya bacakan. Terima kasih atas perhatiannya. Mohon maaf apabila hal-hal yang kurang berkenan. Wabillahi taufiq wal hidayah. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Terima kasih banyak Bapak Erlangga selaku Direktur Bendungan dan Danau atas keynote speech yang telah disampaikan mengenai bagaimana pentingnya bendungan di Indonesia dan juga bagaimana pemanfaatan teknologi yang saat ini sudah dikembangkan oleh Kementerian PUPR yang ternyata tidak kalah menarik juga dengan pengalaman-pengalaman yang ada di internasional. Nah, harapannya nanti akan ada ketersinambungan dari apa yang saat ini sedang di-develop atau dikembangkan di luar negeri sehingga dapat juga dipelajari dan sekiranya menjadi masukan untuk perkembangan teknologi modern dan pemanfaatannya untuk bendungan-bendungan di Indonesia. Baik Bapak Ibu, marilah kita memulai inti acara pada siang hari ini, yaitu sesi paparan narasumber dan juga diskusi. Sesi pertama akan membahas topik mengenai the advanced technology of satellite image for dam safety and operation. Nah, berbagai narasumber akan menceritakan pengalaman manfaat penggunaan citra satelit untuk keamanan serta operasi dan pemeliharaan bendungan. Sesi pertama ini akan diserahkan sepenuhnya kepada moderator kita hari ini, yaitu Bapak Muhammad Irfan Saleh. Bapak Irfan Saleh merupakan Direktur Sumber Daya Air di Kementerian Perencanaan Pembangunan Nasional Bappenas. Untuk mempersingkat waktu, kepada yang terhormat, Bapak Muhammad Irfan Saleh, waktu dan tempat kami persilahkan.
Ya, terima kasih Bu Tara, Pak Erlangga yang terhormat, Bapak Ibu, Pak Ilham, teman-teman semua. Kita mulai sesi pada siang hari ini untuk bisa mulai mendiskusikan beberapa terobosan kita nanti ke depan dalam rangka meningkatkan kinerja pengelolaan bendungan kita, terutama terkait dengan keamanan bendungan. Dan welcome Pak Isbran Asel and all the team from the World Bank and also the panelists. Today we will have some
greetings to you, Pak Irfan.
Yeah, Pak. We will have a discussion in this first session. We will have a panelist here from several organizations and international organizations that are related with the utilization of spatial data and remote sensing for dam management. Saya perkenalkan pertama mungkin dari Pak Paulo Mazzati. Welcome Pak. Are you already in this webinar as well? Maybe sudah.
Good morning.
Good morning. Oh, morning. Yeah, good afternoon in Indonesia time.
Yeah, it's quite early this morning in Italy.
Sorry to make you wake up earlier here today. And now, and also we will have Ibu Marta Roca, the Principal Engineer for Flood and Water Management in Wallingford.
Hi, good morning.
Good morning, Bu. And also Marcelo Leite Ribeiro, the Head of Water Resources and Energy Department of the HYPOS Consortium. Good morning.
Good morning.
Okay, before come to the this session, I will maybe get the setup of the discussion today, and maybe I will try to speak in bahasa first because most of our participants also from Indonesia. Jadi Bapak Ibu sekalian, kalau kita siang ini melakukan diskusi dalam rangka bagaimana sharing knowledge mengenai pemanfaatan remote sensing dan satellite image, dan tadi mungkin Pak Airlangga sudah membuka dengan beberapa terobosan yang sudah dilakukan oleh Kementerian PUPR dalam rangka pengelolaan data dan informasi di Kementerian PUPR. Kita melihat bahwa pada siang ini banyak sekali kalau kita lihat teknologi di dunia terkait bidang digital gitu ya, dan IT berkembang sangat pesat. Bahkan kalau kita lihat perkembangan teknologi yang pesat ini setiap 5 tahun sekali atau 10 tahun sekali, bahkan teknologi yang dulu sudah pernah kita miliki itu pasti akan berubah sangat cepat dan lebih efisien dan lebih murah. Dan ke depan kalau kita lihat ini yang membuka kesempatan kita bagi Indonesia bahwa sudah saatnya kita memanfaatkan fitur-fitur teknologi ini dalam rangka meningkatkan kinerja pengelolaan infrastruktur kita, terutama di bidang pengelolaan bendungan. Kalau kita pahami memang kita di Indonesia sudah memiliki banyak sekali bendungan, hampir 200 yang sudah kita miliki dan kita bangun, dan sekarang banyak hal yang sudah kita lakukan juga dalam rangka meningkatkan kinerja bendungan tersebut, seperti yang mungkin disampaikan Pak Airlangga tadi. Dan kalau kita, kita sudah hampir punya 300 bendungan ya, dan mostly dikelola oleh Kementerian PUPR, sekitar 262 bendungan, dan ada 31 bendungan yang dikelola oleh pihak swasta dan kementerian lembaga terkait lainnya. Dan kalau dilihat dari situ, kita menghadapi sebuah kondisi bahwa dari sebagian besar 293 bendungan tersebut, banyak yang sudah melewati usia efektifnya dan sekarang masih beroperasi, dan ada juga yang baru dibangun dan menghadapi kondisi perubahan catchment area dan pola climate yang berubah, sehingga sekarang kita menghadapi tantangan baru bagaimana kita dengan prasarana yang ada ini bisa tetap mengoperasikan bendungan kita secara lebih efektif. Kalau kita lihat upaya kita selama ini dalam mengelola bendungan, kita sekarang masuk pada aspek-aspek yang lebih substansial gitu ya, bagaimana tadi dengan tantangan yang kita miliki, kita perlu menjamin bahwa dari sisi keamanan bendungan tersebut bisa tetap terjamin, dan dari sisi keandalan operasinya dan sisi layanannya juga bisa tetap optimal. Dan ini yang selama ini melalui beberapa program yang dilakukan di APBN maupun sekarang kita ada DOIS Phase 2 yang sekarang fokus pada bagaimana meningkatkan kinerja bendungan yang kita miliki dengan melakukan repairment and rehabilitation, dan kita juga menurunkan risiko dari bencana yang akan terjadi atau tingkat risiko dari pengelolaan bendungan yang kita miliki secara keseluruhan. Dan kalau kita lihat sekarang, satu hal yang perlu kita pastikan ke depan bahwa dengan pendekatan baru kita dalam mengelola bendungan yang lebih terpadu dan terintegrasi seperti ini, kebutuhan kita terhadap data dan informasi serta dashboard atau sistem yang bisa menjamin pengambilan keputusan secara cepat itu sangat dibutuhkan, dan di situ teknologi-teknologi yang kita miliki sekarang sebenarnya sudah bisa mendukung kebijakan kita tersebut. Ini hari ini inisiatif dari teman-teman di World Bank melakukan dam safety from space. Ini sebagai salah satu upaya kita untuk terus belajar bagaimana memanfaatkan teknologi remote sensing dan teknologi pengelolaan data dan informasi di bidang water resources untuk bisa meningkatkan kinerja pengelolaan bendungan kita. Kalau kita lihat sekarang, kita sudah banyak sekali target yang memang dibebankan gitu ya terhadap infrastruktur dalam rangka menyediakan air dan menjamin bahwa layanan air ini juga sejalan dengan penyediaan dukungan terhadap sektor lainnya, baik itu di bidang pangan maupun di energi. Kalau kita lihat sekarang, sebagian bendungan kita desain dan kita set untuk bisa memiliki fungsi yang multi-purpose, dan satu hal yang perlu kita lakukan bahwa pengolahan bendungan yang sifatnya multi-purpose tersebut juga membutuhkan kemampuan kita yang lebih baik dalam mengelola bendungan ini secara lebih sistematis dan secara kuantitatif bisa terukur. Dan ini yang mungkin bisa jadi sebuah PR kita ke depan gitu ya, bahwa bagaimana nanti pembangunan di Indonesia, terutama kita di Bappenas juga sedang mempersiapkan Midterm Development Plan 2025-2029 RPJMN, dan ini yang tetap akan menjadi satu prioritas kita ke depan, bagaimana optimalisasi dari bendungan-bendungan yang sudah kita miliki tetap bisa kita tingkatkan dan keamanannya terus bisa kita perbaiki. Dan beberapa tantangan tersebut mungkin dari sisi teknikal kita sudah mengidentifikasi beberapa tantangan yang kita sudah miliki, termasuk juga dengan perubahan iklim dan land use yang ada terjadi sekarang di kawasan sekitar bendungan, yang juga menjadi tantangan ke depan. Kita lebih bisa melakukan measurement yang lebih efektif dalam mengelola bendungan. Dan di sisi lain kita juga menghadapi masalah di sisi regulasi dan administratif setting. Bagaimana sekarang secara formal kita meminta bahwa keamanan bendungan ini menjadi sebuah proses yang diformalkan gitu ya dalam kelembagaan kita di pemerintahan. Dan sekarang kita melakukan banyak sekali proses sertifikasi dan proses pengujian dan asesmen terhadap kondisi bendungan yang kita miliki. Dan semua hal ini kalau kita lihat berujung pada kebutuhan kita untuk lebih meningkatkan kemampuan mengelola data dan informasi dengan baik. Siang ini kita sangat berterima kasih pada panitia karena sudah membuka kesempatan kita untuk belajar lebih lanjut mengenai teknologi-teknologi yang ada sekarang di dunia dalam memanfaatkan fasilitas teknologi remote sensing dan pengelolaan data dan informasi digital di bidang pengolahan water resources secara umum dan khususnya terhadap bendungan. Dan ini yang akan kita pelajari lebih lanjut. Di sesi 1 ini kita akan banyak mendengar tentang bagaimana pemanfaatan information system dan satelit teknologi ini untuk bisa mengelola bendungan dari para narasumber. Dan mungkin untuk mempersingkat waktu, saya cukupkan pengantar untuk diskusi kita nanti yang diawali oleh paparan dari para pembicara. Dan semoga nanti kegiatan ini banyak menjadi sumber masukan bagi kita dan insight dalam mencari atau melakukan inovasi memperbaiki kinerja pengelolaan bendungan kita ke depan. Nah, mungkin dari pembuka dari kami seperti itu. Dan saya yang sekarang mempersilahkan sesi 1 ini kita mulai dengan panelis 1. Now I let Pak Paulo Mazzanti to present his concept related to the use of remote sensing for dam safety monitoring on landslides, earthquakes, and subsidence. Okay, Pak, the screen is yours. Now, you have about 15 minutes, Pak. Please, you can start.
Good morning, ladies and gentlemen. Can you see my screen?
Yes, Pak. Please continue.
Good. Thank you very much. Thank you for the introduction, and thank you for inviting me. I'm very happy to be here and to give my talk this morning or this afternoon in your case. I've never been to Indonesia, but I know, of course, very well the country, and And I think there are also some similarities with Italy for a certain point of view, even if we are so far. We have no elephants and tigers, but we have volcanoes, we have earthquakes, we have landslides, we have more or less the same number of large dams. So that's another interesting, even if in our case, most of the dams has been built several years ago, except for a few cases. And so they are reaching almost all of them, their expected age. And so managing is now much more important. Quick introduction of myself. I'm a professor at the University of Rome Sapienza, the largest university in Europe. I'm a geologist as a background with a PhD in earth sciences. And I'm teaching at the university exactly remote sensing and geological risks. So what is the topic of my presentation is perfectly in line with what I do every day. I'm the organizer of the international course on geotechnical and structural monitoring. Is an annual course at the international level focused on geotechnical and structural monitoring. So if you want to take a chance to visit Rome next year in May, that's a good season as well for visiting Rome, not too hot. Take into consideration this course as well. And some years ago, I founded with some colleagues NAZCA. NAZCA is a spin-off of the university. Was a company that was born exactly with the purpose of transferring knowledge coming from the university into the industry and practice, as we realized that several technologies were becoming much more potential effective for the industry and for the daily practice. And this company deals mainly with satellite and terrestrial remote sensing technologies for natural hazards control and assessment. So that's what we do. Let's jump to the main topic. And of course, today we are talking about dams. Dams are a very complex environment done of some structures that want to avoid that all the water go below the river in the valley. But at the same time, when I talk about dams, I consider something like this as well. So dams are creating complex environments, not just the new structure that is being to block the river. It's became very often a huge lake. It became some very beautiful places. The image in the up there left is a very beautiful dam in Italy, not far from my original country house. Here we are on the right in Africa with one of the longest dam worldwide. And so, of course, when we impact so much, potentially also positively in the environmental point of view, you have to consider not just the dam itself, but a wall basing. And when you are dealing with a lot of large areas, and as was mentioned before, when some of these dams are located remote and not easily accessible, it's very challenging to make some control. And so from this point of view, what's happened in the last few years and decades is really what I am used to call the remote sensing revolution. There was a so rapid evolution that from my point of view is more a revolution than an evolution. The two main technologies that is driving this this change are satellite and UAV, so drones. These two technologies are definitely the potential to change the way, and they are changing the way asset management is performed. As they are growing day by day. Every day there is a new satellite that is launched on the sky. Drones are today in the hand of anyone, especially young generation are using so much. I think that as we have mobile phone in our hands, probably in the next few years, anyone will have its own drone to make a flight. So it's something that is becoming also very, very popular and easy to use. And so starting from this revolution, the relevant point is that satellite and also drone in the near future we collect data independently from our request. So today, if you want to collect some data, you have to go in one site to install some instrument and to be there and collect this data. Right now, for example, already with satellites are orbiting around the Earth. There are some satellite missions that are collecting data every day in different wavelengths. Some of them, including radar that was mentioned in the intro, are the capability to look during the night, through the clouds. So whatever is the weather condition, they can see at our asset and our structure. And so how they are used today, there are some technologies that are becoming common, taking a drone and making a flight and collecting a 3D model of a dam, for example, or a slope. It's something that is, I don't want to say is the daily practice, but we are close to a standard application that most of the people can do. There are easy softwares, cheap tools for collecting 3D data. It is important to do it well, but the potential to have a digital twin of all our structures today is definitely a reality. But what I want to focus on in my talk is mainly the 4-dimension. So from 3D to 4D elements, and the 4-dimension is time. We all know that what is happening today can be different from what is happening tomorrow. If we talk about landslides or heavy rainfalls or earthquakes, all these events, geological events that in some cases are not easy to be predicted, can change the situation. And so considering our world and our structures and infrastructures as static, I think is a mistake. We have to consider that everything can change. It is not changing necessarily in a continuous way, because there can be events that can change suddenly what is the situation. So time is very important. And if you look at this picture, this is a short animation, you see how this basin is changing. You can see different things. Just looking at this short video of different sedimentation, different level of water in this basin, different behavior of the river upstream, and so on. And the lower thing that you see is the dam itself, but it's the whole environment. At the same time, looking at a standard river, you can see what is happening here. There are, you can easily, with such a color, I will use a lot of colors here because I think the colors impact quite a lot in the capability to understand, also for not very expert. If you see this, let's say violet colors here, are all the change that happen in this river in almost 1 year. Just to see how much dynamics are water-related connection. And this is another area where in violet, you can see in radar images, the more humid areas that can be detected from space. And so change of humidity can be an impact for water management and so on. But of course, I will jump more in the focus of my presentation, and I think that change detection over time is a very powerful tool also for hazards. In this case, you see this picture. This is a very standard picture. Is an optical one collected by Sentinel-1 satellite, Sentinel-2 satellite, sorry. That is an optical system, 10-meter resolution, not very detailed. But if you see the difference between two images that I'm switching right now, you can see some differences. And with very simple photo monitoring tools, you can identify what are the changes. And you can identify that this river here was affected by a debris flow that reached the main river during an important event. What is interesting of this case is that you can look very far from the road that was here up on the mountains, just comparing two images. But what is even more interesting is that you can look also more far from here and look in an area that was not considered relevant just because nothing happened at the valley level, but top on the mountains, there was another debris flow. And this debris flow that entered in the river, maybe in the next flood or in the next rainfall event, can be the following causing problems at the valley level. So that's an important from my perspective, that looking with a satellite system that look at wide areas may help in detecting and predicting what may happen in the future. With the same technology, if you have, for example, 1 image per day, you can see, like in this case, a landslide that is evolving, reaching its total amount of displacement, like in this case. And here we are in Peru, and we can do this from Italy without any issue, because satellite has this great potential. You can detect how it's moving, how much, in which direction, and so on. And if you have several images for each point, you can have a time series of deformation that can show when this movement occurred, if it is steady, if it is accelerating, or so on. Of course, same technologies can be used for earthquakes. Unfortunately, as we know, predicting earthquakes is not an easy task today. We know where they can happen, but once something happened, you can immediately make a check with satellite images. And in this case, for example, it was possible to measure all the pattern of deformation across the fault. You see the difference between blue and red, yellow colors. This exactly identifying the fault system. And the movement that was occurred in this case, this was not a so strong earthquake. We are in California. Was about 30 centimeters of deformation. It was possible to detect it. And please consider that this was done with a 10-meter pixel image. So this is an important point, because also with coarse resolution images, you can reach very, very high detail with such technology that is called digital image correlation technology, and is one of the photo monitoring options that we think can really help. Of course, the same thing can be done also with a drone. So remote satellite is not the only remote sensing option. In some cases, you have to go into more detail. And for example, collecting 2 surveys, let's imagine to make a survey by drone every year, every month. In some mining facilities around the world, there is now plans for collecting every week a flight with a drone. But these images are just taken and put into the folder of the computer and not really used. If you use it, if you compare it, if you use the 4-dimension, you can detect, for example, this more change in these blocks of concrete that they are moving. And you can predict a larger failure, for example, based on this information. Same things can be done for landslides. This is a landslides over time with multi-temporal UAV images. But what is good from my side is that potentially you can go also into the field, because there are some technologies, in some cases driven and developed from satellite, that can be used for monitoring. As a simple camera of a few €1,000 can become a monitoring system. And that's the power of photo monitoring. If you look at these 2 images, maybe you don't detect some relevant change on the slope, but if you process with photo monitoring technologies, you can detect all those pieces of rock that fell down from this cliff, detecting the more active areas, understanding the sides, and understanding where the more active events can happen. And this is just using a very, very simple camera at several 100-meter distance. If you then use something that like these robotized cameras, that also in this case there are very accessible and cheap tools that could be installed potentially in any dams with a very affordable cost. And that's interesting to say that this kind of technology is called Gigapan technology, was originally developed for the space industry, for taking pictures on Mars, for the Mars exploration missions, and now is down to the Earth for terrestrial application. In this case, we were able to detect in 3 days 80 small rock faults occurred. Very, very small pieces of rock. Are they relevant? Maybe not immediately, but maybe an indicator of an activity of somewhere that can happen. We can see this today. There are all the technologies. And there are also webcams installed. And the path of deformation of these landslides was just detected with a webcam of 200 euros cost. So really, really cheap tool that anyone can afford and buy. And so that's another important point. This is another example of landslides monitoring with a webcam. And this is something even more challenging, is the monitoring of landslides monitoring and a landslides event just with 2 images taken by a mobile phone. This one, my iPhone system. If you analyze and to compare 2 images collected at different times, with the red color, you can see the differences. You can see where landslides occurred, where something happened, and so on. So there is a wide spectrum of opportunities, also with simple images. When simple images, optical images are not enough, you can go to the radar. And with radar, you can monitor dams, like in this case, with a very high accuracy. And this is interferometric results that was already mentioned. You can be very accurate, so that accurate with some high resolution satellite that you can see the seasonal brief of the concrete dam in this case, potentially the cyclic deformation. But what is fancy from my point of view is that you can analyze large areas. And for example, you can detect remotely in these very dangerous areas in Sudan, you can detect this crack long 11 kilometers that was not known before, just using a simple interferogram, like in this case, and then send people into the field to check, of course, what is going on. At the same time, with satellite INSAR, you can identify huge, massive slope deformation. Imagine that this is the lake, you can see very well. This is the dam itself. This is a massive slope deformation. Fortunately, is going not in the direction of the basin, but on the opposite slope. So maybe it's not an issue. But in some other cases, you can have massive slopes that move toward the basin. And this is the arch dam here. That's the side. These few points are the dam. This is the slope. When you have something like this, and unfortunately in 1963 in Italy, you probably know, you experienced a very tragic landslides failure. That was mainly not a dam failure, but a landslides failure in Vajont. For those that didn't know, I suggest to have a check on the web. We can have the tool today to understand what is going on, the size of a landslide, what's the rate of movement, and this is everything done by satellite data. And this is another case. This is at the border between Italy and France. This is an earth dam, and this is the huge, massive slope that is moving, and that was not known before, just because we are in the high mountains. Very often there is no weather, no matter, we can in some way monitor. Last slide is referred to events in let's say flat areas and not in the mountains. This is a tailing dam, so it's a dam but used for mining activities. And this dam is quite famous, is the largest in Europe of this type. They are very dangerous. We had about huge problems in Brazil a few years ago about the collapse of tailing dams, and they can be easily monitored by satellite as well. So now these plants at European level are becoming standard. So the whole Europe is monitored by satellite, also at the public level. Of course, once you have this data, the translation into information is not so obvious. And I want to focus and conclude with this point. Data are not information. Information can be derived from data. Data can be achieved, but then there is the need for geologists, engineers that are able to translate. And what is important is to use these tools for taking decisions. Otherwise, they are just colored points that can be fancy, but not really useful. This is what I think in a good process for asset management is the direction we have to go. So this is the end of my presentation, and I thank you very much for your time and your invitation.
Thank you, Bobo. So very insightful introduction for this session about the utilization of spatial technology now. We have this UAV and satellite to get the fourth dimension of our analysis, time dimension, and I think that's will become maybe very helpful to analyze many sectors, including the landslides and also their management and also the condition of the catchment. Okay, maybe we can we move to the second speaker. We have Ibu Marta Roca.
Hello, yes. Good morning.
Good
afternoon.
Good afternoon. And the topic is integrating the satellite dataset relevant to dam monitoring using DAMSAT and development of emergency plans through flood risk mapping. Okay, Ibu, the screen is yours. You have 15 to 20 minutes. Please start.
Thank you. Thank you very much. I'm hoping you see my screen. And yeah, I think my chat fits very nicely with the one from Dr. Mazzanti, really. First of all, hello, everybody. I'm Marta Roca. I'm a principal engineer from HR Wallingford. We are a research and consultancy institution in the UK. And the purpose of my presentation today is to talk a bit about DAMSAT, the system that we developed to monitor dams from space. Oops. So what is DAMSAT? DAMSAT is an operational system. So as Dr. Mazzanti was saying, we try to go from the data to the information side to support the taking decisions. So DAMSAT is an operational system to monitor waters and tailings dam and also other tailings deposits, and is based on satellite information, but not only satellite information. We also manage we also take into account other types of information. And the idea is really to provide a better understanding of the risks and support the decision making. So, what is DAMSAT? DAMSAT is a website-based tool that has different modules. And you can see here on the screen, all these different icons are the different modules of the DAMSAT system. So we have a module that provides information of a particular site, a module that provides information of possible leakage, movement, the hydrological forecast. In the case of tailings dams, how the tailings beach behaves, the amount of tailings beach, and also some modules about emergency planning. What happens if a failure occurs? And all this information is compiled together, and some warnings and alerts are raised if something anomalous happens. Most of this process involving DAMSAT, in all the information that is managed in these different modules, most of it is automated, but of course there are supervised processes that need the inputs of engineers and dam specialists. The data sources that DAMSAT is using is basically satellite information, optical images, INSAR information, but not only that. We also use, if there is this information, data from in situ sensors. So the idea is really to complement information from satellites, from measurements in the ground, but we also use numerical models that are linked to this data just to get more information and more detailed information. So maybe what I'm talking is a bit too general, but I'm just going to show you a couple of images of how the DAMSAT system looks like. We developed DAMSAT in Peru. this was a UK Space Agency supported project, and we focus in Peru in some of the main mining regions because, as was said previously, tailings dam can be quite a damaging asset if a failure occurs. So what you see when you enter into DAMSAT is the general map of the region, and then when you click in the region that you are interested, here we were focusing in these 3 regions, then you go to the regional level. So you get a map, a more detailed map of the region you are interested. And you can see in this screen, these little icons, these little triangles, and these are the different assets, dams or tailings dam deposits that we were monitoring. So in a region, you have different assets. And then when you click in one of these assets, you go to the page that shows you the information for that particular asset. And here, as you can see, there appear again all these icons, all these different modules. So at asset level, you have the information, the detailed information about the site, about possible movement, and so on. So what I'm going to show you now is not all the modules of DAMSAT, but just some of them to give you an overview of what you can see. This is, for example, we have the hydrometeorological module. In this module, what we do is we take the data from the weather forecast, and in this particular case, we are using information that is updated 4 times per day. And what we do is to use this information, we apply hydrological models, and we estimate the possible changes in the reservoir water levels. So this helps the dam operators maybe to take early decisions from this forecasting data. So as you can see in the image, you have the rainfall forecast. We estimate with the models the runoff and the water level increase at the dam with that particular rainfall. So this is an example of the results that you get in one of the modules. Another one is movement detection. And as it was mentioned before, we use the interferometric results. We use the radar, the INSAR information to look at the possible movements at the dam. And here what you see in this image is you see the crest of a tailing dam, and all these points, this is the downstream slope of the dam. So you can see that the orange color is movement away from the satellite. So there is some consolidation of materials at the top of the dam, and the white dots mean that there is no movement. So this INSAR information is very useful to detect possible changes, possible movements at the slope of the dam or at the crest, of course. And here again, there is plenty of different sources of information. We can use low resolution images that in most of the cases, they are free. And you can already get quite a lot of good data, but you can also use, of course, high resolution. You will have more detail, but the images are more expensive and the processing of the images is a bit more complicated. Another module that we have focused on the tailings dams is the tailings beach module. Here what we do is from optical images, we estimate the percentage of beach and water. In Peru, the legislation is such that there is the design of the tailings dam needs to have a particular amount of beach, of material in front of the dam. So it's not good that water is in front of the dam, as in water dams. So what we do here, and I'm showing you in this image, you see on the top the dam, the tailings dam, and you see the water, the area in blue. And what we calculate is the percentage of water and the percentage of tailings deposited, and also the distance of this surface of water to the dam, because this is something that also the national authorities need to monitor. So as you see on the right of the image, you get the percentage of beach and the percentage of water in the reservoir area. But of course, because we are dealing with optical images, there can be clouds as well. So we need to take into account the uncertainty caused by the clouds. And on the bottom image, you can see that you can have this information every time that you get a satellite image. So you can have a record of the evolution of what has happened in time. Another module that we have is the emergency planning module. And the idea of this module is really to support the understanding of the risk downstream a dam if a failure occurs. And for that, we use a set of models. We use a bridge model that connects to a flood spreading model that then connects to an evacuation model, a model that helps us to understand how people behave. So I'm going to give you a little bit more of detail of these different models. First of all, the dam bridge. We use for that software that we have developed, the Umbrea and the Umbrea Mat, that take into account the failure modes of dams in different types of embankments, and also considering the different types of failure modes. So you have an online version available of some of these software in the link I'm showing there. We have also a similar module we call Ariba, that is a module is a model, sorry, specific for scoping or probabilistic studies, when maybe you don't want a lot of detail in the information, but what you need is a lot of data. So this is a model prepared to with a very quick runtime of less than a second, just to get a lot of results and explore a lot of possibilities. So we use this, the Umbrea and the Umbrea Mat for the tailings. When the Umbrea is used when you have a water dam, Umbrea Mat when you have a tailings dam. We use these models to simulate the breach of the dam, and then we simulate how this is spread downstream. So what we do, we use different types of models to calculate the flood extent, the water depth, the flow velocities downstream. And this helps us also to identify the critical infrastructure that could be affected and to estimate the damages downstream. And you can do this at different levels, from a relatively small catchment level to national level. And for example, we recently developed this type of studies at the national level for countries in East Europe, like Bulgaria and Moldova, where we really monitor the whole country. And also to mention that these flood spread models can be used in real-time forecasting. And we have helped the national government of Malaysia, the institutions of Malaysia, to set up their flood forecasting model center, sorry. So the dam breaches, we estimate how it is spread downstream, and then we study how this will affect people and how people will move or will interact with this flooding. And for that, we use a life safety model that is what is called an agent-based model that really looks at the behavior of people or vehicles or in time and space. And this information is really useful to develop the emergency plans, to decide, for example, where are the safe places where people can evacuate, or which are the areas more affected. So what I'm going to show you now is a short video. Here we simulated in the bottom of the image, there is the dam that you will see that it breaches and then it spreads downstream in this area. All these violet dots represent the people, and people changes color as processes develop, as they are aware, as they start to move and go to the heaven, to the safe areas. So if we look at the picture, you see people now is aware, people start to move. So when the dam breaches, in more or less an hour and 20 minutes, it reaches the area of the town. But the people, if there is a warning, the people has been able to really go to safe areas. So these type of models are very useful to analyze different scenarios, what happens with different warning times and how much warning people need, and so on. So this is a very quick overview of some of the DAMSAT modules, but the idea at the end is that DAMSAT wants to support operators and public institutions really to assess what's the status of the different assets, taking into account that sometimes some of these dams and assets are in very remote locations, so you cannot go and visit them as often as you would like. It provides a better understanding of the risks if something happens downstream, contributes to take early decisions and the reduction to the downstream possible impacts. So the idea of DAMSAT, as it was said before, is to help the decision making and reduce losses. You can find more information in the damsat.com website and also at hrwallingford.com website. So thank you very much.
Thank you, Martha. The presentation about DAMSAT, I think, yeah, more information we got this afternoon about the utilization of the data satellite, and I think you combine this satellite data in situ sensor set numerical models to develop the modules that will become basis for decision-making process. And thank you very much for the presentation. Now we move to the third panelist, Marcelo Ribeiro. It's already okay. He will talk about hyposynthesis, a web-based sediment analysis using satellite image and operational hydrological forecasting system. I think this is another utilization of this satellite data. Please, Pak, the screen is yours. You have 15 minutes.
Yeah. So thanks very much. I think Mrs. Jacinta, she's sharing my screen. I hope we all see that. So thanks very much. Thanks for the invitation. So having the opportunity to share some of our tools and knowledge here with you today. So I'm Marcelo Ribeiro. I'm head of the Water Resources and Energy Department at Gruner. So Gruner is a Swiss engineering company working on the energy field, especially in the hydropower and dam design and dam safety aspects. So I'll be talking today about these two tools that we have, this HYPOS tool and the TETIS forecasting system. Next, please. So as we know, in order to achieve the long-term safety and long-term benefit of a project with a sustainable project, we need an adequate design and an adequate operation of the infrastructures. And in order to do that, we need data. We need reliable data. So we start with this, this first point that the data, as we know, is key, but not only data. We need reliable data. Next, please. So the presentation today is divided into 4 parts. So we will be providing you our vision about the data and the current situations. So we will be talking about HYPOS and TETIS. So these two tools that we have, they are more linked to the sediment and hydrological forecast. So they can be used in separated, or they can be used together. So there's a synergy between them. And some key takeaways in order to reply to the main questions of this webinar today that are shown here that we all know, but basically what are the limits of the technologies, what can be done to improve dam safety in Indonesia, the limitations that we have today, and what would be the priorities for investment in dam safety in Indonesia today. Next, please. So we all know that there's a big amount of data available today, and it's really increasing in an accelerating rate. So that's something that we all know. Our colleagues today mentioned about drones, satellites, and all kinds of ways to get data. We also know that the artificial intelligence and the tools for data analysis are keep improving. So all of this is very positive on what we are doing, the way to improve dam safety. Next, please. But on the other hand, yeah, can you put the next? Yes. So on the other hand, large dams are major infrastructures, and that they can be very, very dangerous when we design and operate them not in an adequate way. We also know that the reliable field measurements are still essential. Even with all, it can always be completed with the EO data, so Earth observation data, but then we know that having a reliable field measurement that we can trust and we see, it's still essential. Not all the EO data and the artificial intelligence are developed with the top reliability and precision in mind. We know that, for example, we can tolerate some errors when we are looking for. We're using search engines like Google, for instance. When you go to look for something, we can tolerate some errors in that. But in large dams, we cannot tolerate. And we also know that the dam operators are typically conservative and suspicious of these new technologies. It's very easy to them when they have experience to change the way of their operating them, for good and for bad reasons. Okay, next, please. So when we are developing a project, we have to acknowledge that there's a big potential, huge potential of applying EO data and its analysis for the development of the project. Again, I'm concentrating here on the water and the sediment part. So for the water part, we can quantify water resources with precision without, and that's important, without need to significant investments and waiting for the data to be collected. In a project, we know that there's this in the beginning of the project that data collection is quite expensive to the promoters. Normally, the promoters and the developers and the ones that are public institutions, they are using their own money in the development phase, so they have a limited budget. Then it's very difficult to them to go and to start putting money on the collection. So EO here can really help on that. And we also, the reliability of estimated extreme values and investments necessary to guarantee the safety of the dam. So we can using the EO data, we can reach that reliability if used in a good way. Next, please. On the sediment part, and again, that's also important. Most of the dams now constructed in remote areas. With colleagues today, they mentioned that, where there's no data. So when we are looking to the sediment data, we can evaluate potential issues with sediment early in the project. So that's something that we can get with this data. And then we combine the water and sediments, we can also assess how the climate will influence the sediment cycles and evolution during in the future, the operation. Next, please. Operations. So when we are operating a hydropower plant or a dam, we know that the operations, the decisions are driven by really short goal terms. So when we talk about operations and then forecast, we know that the forecast, the seasonal forecast, is not particularly reliable. And then the risks that we use that forecast to optimize the operation, so the seasonal forecast, so that's risky. This is a risky business, and we also have the risk here that we overthink seasonal plans, and that expose the operators and the society to the issues like droughts and loss of profits. This is, as I said in the beginning, these are normally using short-term goals, and we also see that there's a proactive operation of the reservoir can really improve dam safety. So basically, not using the data, also this seasonal forecast or this let's say standard rules that we have, but really putting the efforts on the proactive operations of the reservoir with long-term goals. Next, please. When we talk about sediments, we all know that the sediments they can lead to important problems and issues in dams and hydropower. So they can block. So the accumulation of the sediments in the reservoir can lead to the blockage of outlet structures. So ultimately linked to the dam safety. Basically, we cannot really operate the structures that are used to operate when it's necessary. And but we also know that the slow but steady evolution of the sediments, they often lead to problems and normally fly under the radars of the operators until it's really too late. So basically, people we forget about the sediment issues, and then sediments are just accumulating, and then suddenly the problem is there, and we can there's no solution. Next, please. So now entering to the main part of the presentation. So the first tool that we developed is the HYPOS. It's a new tool for technical sedimentations. I'd like to give credit to our partners in this project that is financed by European Union under the Horizon 2020 project. So we have in this the joint venture with other companies and institutions like IOMA in Germany, SMHI Sweden, CNR in Italy, and NTNU in Norway, together with us running on that journey. I put here very examples of issues that I just mentioned about sediment problems that we can have. We can have on one hand abrasion of turbines, for instance, so that's more an economic issue. But we also have abrasions of infrastructures like tunnels, where as you can see on the right hand image. And in the middle, we have one of the biggest dams, largest dams in the world. It's Inguri in Georgia, where we know that some of the bottom outlets are blocked today and cannot be opened because of the sedimentation upstream. Next, please. So what is HYPOS? It's a web-based tool that combines satellite data with hydrological model, in situ and field monitoring, together with the market capacity assessment, in order to define the cost-efficient, easy access easy access to improve hydropower design, planning, and operation. So basically, the core of the system is that we can collect historical data on sediments, so total sediment concentration from satellite image. It's a key information that we can have. Again, especially in the remote areas where there's no data at all. Next, please. So what we get in Hypos, that's an extract of what one of the projects we have here is a dam in Albania. We can see, so the blue curves on the top of the image here, the graph, is showing the historical evolution of the sediment, of the turbidity downstream of the dam. And when we compare, when you put it in perspective on the bottom graph, where the yellow curve is showing what is the sediment concentration coming into the reservoir. So we can see that the big difference there. So that information, when we combine that information of the sediment concentration with the hydrological model, so with let's say the hydrological series that can come from hydrological models or from field measurements, we can get a sediment. We can find total sediment, suspended sediment transported in the reservoir. So that's something that can be, we give an example here, but we can apply that worldwide based on the satellite images available today. Next, please. So what are the benefits for the dams and hydropower? In this case, with Hypos, we do have an easy access to the key hydrological and water quality related information. Again, sediment regime, sediment trapping, water quality parameters that give us also good access to the analysis in transforming this. We can use that data, transform that data, and transform it into an actionable information that is customized for each user. So that's the key point that we need to concentrate on it. So the data is not enough. We need actionable information from that data. That's what we are looking for. Also, with that, we can give a near real-time monitoring of the sediment management in rivers and reservoirs. And now we have the link with the TETIS. So having that information from some satellites, and so this is historical information, we can link that to the forecast of reservoir management tools that comes with TETIS. So next, please. Now
3 minutes left.
Yeah,
please.
Okay.
Yeah.
10 minutes.
3 minutes.
3 minutes. Okay, sorry. So when we have that now, I try to go fast. So we have that's a probabilistic forecasting system. Why another system? So many dams are operated without a real forecasting system. There's large financial losses. All of the current standard forecasting system use ensemble forecasting that has its limitations, and the traditional forecasting for large infrastructures need big data and processing and computational power. Next, please. So what are the risks of using international artificial intelligence in that? They are real. When you talk about floods, if the system has a precision of 99%, it's really likely that it will fail when a large flood with a very low probability occurs. So the system it fails when it's needed. What to do about it? We need to recognize first what are the limits, and the regularizations and linear regularization is dangerous, and linear modeling is safer. Next, please. What is special about our system? We are using machine learning concept to develop the real probabilistic forecast. So we have an ensemble of models that communicate between each other in order to provide optimized one. We build that for reliability. We do have the correct statistical representation of the uncertainty, and can be used for short and long-term applications in different different kind of parameters. It's really easy to set up. We can have a model in a couple of weeks running for whatever place we need, and then using artificial intelligence, we will be improving that application in the results. Next, please. So just there's a very quick image of what the user gets. So we have a continuously updated data on this, again, web-based tool, continuously updated data using the latest weather forecast that's updated also continuously, and we can customize the forecast and the plots depending on the user's needs. We are using that program today in different, and maybe some of the most iconic projects in the world, like for instance the Rogun Dam under construction in Tajikistan. So it's a 335-meter high dam. And the Guri Dam in Georgia, Kabul Abbas in Africa. So those are three of the main projects we have. Next, please. So I come to my last two slides with the key takeaways of this point. So long-term operations of reservoirs are unfortunately based on short-term decisions and actions. We know that there's an increase of available EO and data and tools for treating that, but attention really should be paid on the choice of the tools and models. An optimized field monitoring network combined with an EU data can really improve the availability, quality, and reliability of the data. But most important is the data does not convince operators and people. Actionable information does. So we really need to pass from data to information and decision-making results. There's a growing pressure on the operation of the results on the long term, and on short-term results. Sorry, and that we normally forget about the long-term actions that we need to take to lead to the sustainable life of the project. Next, please. We presented today the Hypos. That is a tool, is a powerful tool that can collect sediment data on areas that there is no data at all. So basically used for the development phase, and also extend that to the areas where there's a comprehensive network, but we can bring the spatial vision of that information. We presented TETIS, that's a reliable forecast system that combines artificial intelligence model with real probabilistic analysis. So we're giving the weight to every data, every result that we are getting. And when we combine them, we have the possibility to have a segment forecast system that's very important for short-term and also for long-term operation of the dams that ultimately guarantees the safety of the structures. Next, please. So, thanks very much for your attention. Sorry for the time, but I think that.
Thank you, Marcelo.
It's okay. So if you have any questions, just please let me know.
Thank you for your presentations. Yeah, we learn more now what the utilization of this artificial intelligence and the machine learning to develop further about our prescriptive and predictive capacity for the development. And I think it's also related to the previous presentations about the utilization of the data in satellite, and also another source of data, including the big data sources that you mentioned related to the spatial data temporal. Okay, now we move to the fourth speaker, Mr. Ion Padilla. He's already here from Switzerland.
Here I am. Hello.
Okay.
How's it going?
We will talk about the radar for improved dam safety and monitoring for disaster prevention and mitigation and optimization of electricity production. Please, Pak, now screen is yours. You have 15 minutes.
Very good. So hello, everybody. My name is Ion Padilla, and I'm the CEO of WeGo. So basically what we do at WeGo is that we combined geospatial data analytics with machine learning to optimize water inflow and water resource management, and obviously hydropower energy production and trading. So basically the situation that we have across the globe is that with increase of energy prices and the volatility of the market, it has become very, very critical that the energy production of hydropower is very, very much optimized, so that the errors that are committed with bad energy long-term trading that require that we buy more energy in the spot market are not as big of a losses as they are currently being. So that's where we show up. We have put together a system that combines several satellites and radar satellites, optical satellites, and primarily all kind of geospatial data sets that we're using, combining machine learning with our fusion algorithm to basically monitor the key environmental variables that are going to be converted into energy through, in this case, the turbine of a hydropower plant. So we're talking about water, obviously, but not only the water. We're talking about snow, the evolution of snow, the water that is stuck in the soil water level, lake volume, and so on and so forth. So all these variables are going to be key into understanding how much water we have available to produce energy today and how much water we'll have in the future. And at the same time, identified as well potential flash flood scenarios or increase water discharge scenarios. So this product has been built in collaboration with the European Space Agency and the Swiss Federal Office of Energy, and it has been validated through datasets extracted with the help of the SLF, Snow and Avalanche Research Institute in Switzerland. So basically, the uniqueness of this product is the combination of multi-inputs data ingestion, right? So I was talking before that we're using radar satellites and optical satellites, but we're using as well drones, helicopters, in-situ measurements, weather stations, so pretty much anything that we can put our hands on. And basically, our algorithm is going to take care of using all these data inputs together in order to produce the data sets that we're going to be working with. So what you see in the screen at the moment is the different data inputs at the bottom, but in the middle of the screen, you will see all the, that's Switzerland, you see Geneva there. There is one of the biggest lakes in Europe in the screen, and then surrounding the screen, you will see in blue and dark blue the snow that we have detected with this satellite technology that is being used in order to estimate the amount of water that is going to be released in the future and then basically arrive in the lake. So all these data sets, we use them in different renewable energies, but today obviously we're going to be talking about hydropower. So we're going to be talking about snow, we're going to be talking about soil water levels, lake volume, the detailed elevation models that we used in order to build our data sets that are going to be used in order to forecast water availability, water discharge. So this is the main geospatial data sets that we produced. We're talking about soil water level, snow depth, melting snow, snow water equivalent, and lake volume. and we offer them in various different through various different interfaces. We have a dashboard that our clients can use. We can send them obviously through email if you want, but we offer as well APIs and different services in order to get access to those data sets. So I'm going to show you the different data sets that we have. The first one is basically related to hydropower, is the data set related to snow. This is not very interesting in Indonesia, but in other locations is very, very important because it's the vast majority of the water discharge that we will be suffering in our different dams. So here you see our snow cover extent that basically it's able to identify pixel by pixel where we can encounter snow. We have as well a product on humidity levels. This we use it for the soil humidity, so we understand the moisture of the soil to monitor the aquifers, and we use it as well to monitor the moisture of the snow as well, so that we can understand when the snow becomes humid and when the snow commences to melt, basically. We have as well what we call snow height, which is we'll go pixel by pixel where we have identified there is snow, how much snow there is, and obviously the equivalent of water. So basically, a product is going to tell us the amount of water that is stuck in the snow. And we have obviously as well the water levels, so soil water levels, that is going to let us know the amount of water that we can see per bunch of centimeters stuck on the soil. So from 0 to 300 centimeters, we can monitor in the whole catchment area how the soil is getting humid and how much water we have stuck on the soil, which is going to be key in order to understand the future water flow that our dam is gonna receive. So with this data as input, then what we do is that we build our hydropower platform. So basically, the first point would be to collect all this geospatial data that is gonna help us kick off the water inflow forecast, which is gonna tell us how much water we'll have in a few hours up to 180 days, with obviously as minimal error as possible that we're gonna benchmark with the previous historical data. And with that, what we're going to do is build an energy model or energy optimizer system that is going to help us optimize the use of water, so that the dam is producing as much energy as possible, and as well optimize the trading of that energy, right? So that we sell that energy as efficient as possible, based on different strategies, right? It could be revenue making, but some companies decide to go for financial loss reduction, right? So ensuring that the revenue is as stable as possible. So there are different strategies that we can follow. So here you can see our dashboard. This is a dam in the limits between Switzerland and Italy. So here you can see the amount of, in this case, snow, and how the snow transforms into water. So at the top of the image, you can see, well, in dark blue, you see snow water equivalent, and in light blue, you will see the water discharge. And in the bottom, you see how we're detecting the moisture of the soil and of the snow, and how as soon as we detect that there is a heavy changes in the moisture of snow and the soil, how the water is immediately after get discharged. Depending on the location, this will take from a few hours or a few days to almost 1 or 2 weeks. So what do we do with these data sets, where we can do things as flash flood analysis? So flash floods in some areas can be created by monsoons. In some other areas can be created by specific combinations of temperature, precipitation, snow levels, and so on and so forth. So basically, we make sure that we produce historical data set in which these variables are going to be measured, so that we can identify and feed our system so that it learns which are the conditions or the preconditions that are going to create heavy discharges in our system, or in this case, flash flood scenarios, right? So you can see top right how we have identified the different flood scenarios or big discharge scenarios, and how that relates to the variables that we're extracting through the satellite data. So on the left-hand side, you can see the moisture, our moisture products, and how they after April more or less they go very far high, and that's a signal that we use in order to make sure that our client understand there is going to be a heavy discharge coming in this case in 4 days. And on the bottom right, you can see how we're monitoring the aquifers, and how the monitoring of the aquifers is making that the dynamics of snow accumulation and melting are way more speedier. So you can see on the right-hand side, the first part of the chart, that the snow takes way more time to melt and the water discharge to arrive, almost 2 weeks. And after the aquifers are filled, that we're monitoring with our soil water level products, you will see how the melting of the snow and the discharge is way more speedier, right? Here you can see as well how we are correlating the water levels on the soil and the future discharge. So this we use in no snowy areas in order to build our long-term forecast based on soil water levels. So you can see that the correlation between the soil water level and the discharge is very, very high, as basically because if there is a lot of soil water level, the precipitation that we'll receive will go directly to the reservoir. It will have low soil water level. That will mean that the precipitation will be stuck in the soil and therefore not reach to a reservoir, right? So it has a heavy correlation between the amount of water that our reservoir will receive and basically the potential heavy discharge scenarios or even flash floods. So the last bit that we do is that with all these data, what we can build is water inflow forecasting system, right? So in this case, I'm gonna show you how our long-term hydropower forecast system works, and this is primarily in this case using our snow water equivalent data set, although we can use as well the soil water level to calibrate it. Basically, what we're doing is that we're looking at months in the future in order to try to guess how much water we'll have. And this we do it by using historical records and calibrating those historical records based on, as I said, the amount of snow that there is in the mountain, the amount of water that is stuck on the soil. And basically, we use this in order to effectively help the traders into making better bets at making long-term contracts with the energy that is being produced. So here you can see on the right, basically how in blue, this is the area that we have achieved to improve. This is a use case that we built in Switzerland. And basically, as you can see, in red, we have the reality, what happened on that year. In blue, we have the average of the last 20 years. And in gray, we have our improved forecast. And as you can see, the system was very good at picking that this was a drier year, so we'll have less water along the year. And you can see how doing a forecast 6 months forward, we were able to reduce the error by 50%, right, which is a huge achievement. So what happens when we do this? The traders are going to be able to sell that energy in a way more adjusted way. So they don't need to adjust that much the energy that they're selling. Therefore, this reduces the financial risk of potential losses if the spot market is higher than our long-term contracts. And it optimizes the price of the megawatt that is being sold. So usually with this system, you can expect to generate, from 0.5 to up to 1.5 percentage of additional revenues, aside of obviously reducing the financial risk. So this means reducing the losses of long-term forecast, as well as using it as well for your own operations, right? We're talking about long-term forecast. This can be very much useful for operation planning, maintenance, and obviously safety as well. So here you can see as well some of the consortium that we built in Switzerland with 9 energy companies, and we're using different partners in order to do the optimization of the battery flow, and how we achieve, as I said, this sort of increase of revenue per ton. So as we go, we are pretty international. We're based in Switzerland, but we operate in Iberia, New Zealand, Canada, and Italy. We're currently generating data for around 34 hydro power plants with clients. So as you can see, we're sort of a multidisciplinary team. Obviously, we have geospatial engineering, but we have as well hydrology engineering, renewable energy, environmental science, and machine learning and AI. So yeah, that's going to be the end of my presentation. If you would have any questions, please feel free to drop them. Thanks.
Thank you, Pak Fadila. Yeah, more insight to the utilization of the data related to spatial data, geospatial data in Earth observations, and I think we got more to learn about the utilization of this data to make a forecasting and improve the service and also profitable action for the company. Okay, that's our the panelists in this first session, and unfortunately Bu Marta already leave because she had another agenda, and we still have Professor Mazzanti and Pak Marcelo and Pak Ion here to continue our discussion. Now we first maybe response to the chat box and the question and answer features. I think Pak Ilham questions about the identification of potential landsliding already answered by Prof. Mazzanti, and maybe we now move to the second questions from the chat box from Pak Hermawan Cahyonugroho, who want to ask the speakers about, is it possible if the satellite could capture if there are any leakages in the dam body? That's the question. Is it possible to utilize the satellite data to capture any leakages path in the dam body? I think Ibu Marta already responds also, but please, Professor Mazzanti, if you want to add more about the utilization of this satellite data.
Yeah, you mean about leakage? So the last question?
Yes.
Yeah, of course. And there are technologies to detect leakage. The problem of the satellite sometimes is the resolution of the images, so it depends on the amount of leakage. If it is a small one, potentially could be difficult, and if it is a relevant one, could be good. There are both optical, but even more radar technologies. There is one technology that was not presented by me, that is INSAR polarimetry, for example, that is capable to detect soil moisture and so potentially leakage. But of course, there is always a matter of resolution. So if you look at the small pieces, potentially you have to go with a drone or with an optical or ground system. So that's, I think, is an important general comment. Not everything can be done by satellite. But on the other hand, I think it doesn't make any sense not to use satellite today for doing some things, because provide opportunities that other technologies are not providing.
Thank you, Mr. Mazzanti. And also, maybe we move to that questions about the utilization of this data to calculate the greenhouse gas emissions for climate change? Can maybe Prof. Masati or another Pak Marcelo or Pak Ion, you want to respond about this possibility of the utilization of data to calculate the greenhouse emissions? Maybe there are some experience for that.
Unfortunately, I don't have experience, so I leave the floor to someone specific.
Yeah.
Mr. Marcelo, please.
In our case, what we can have, when we add that, when we add the information of the inflow forecast, also the inflow and then the energy production, that's something that will come from the hydropower production. We can calculate the greenhouse emissions for that. What we also have is the blue footprint. That's also integrated, but again, we need the information from the operator to have that.
Okay.
So yes, it can be calculated.
I think it's possible to do that. And now the fourth questions from Pak Zulfikar here related to the integration of the satellite monitoring and for flood dam operations that related to the flood risk mapping. It's maybe Pak Marcelo already explained this before. Please, if you want to add more explanation about this.
Can you just repeat the question, please?
How could we integrate the hazard or flood flood risk mapping with the satellite monitoring in the purpose of planning the manual of dam operation?
So basically, you can with the flood hazard maps coming from the hydraulic and hydrological studies. So you can define that map, and with that you can you limit the area right of risk, and then during when you plan your emergency plan, you can have that into account. So basically, that information will be integrated into your system.
Okay, I think that's it means that this flood risk mapping is also possible, and it's important to become one of the feature of the dam operation manual. Yeah.
Indeed. Yeah, that's a key information, because it's limiting in giving you the information what are the risky areas, and then what are the actions that we need to take in those areas in case of risk.
Yes. Okay. Next questions about the monitoring of this dam deformation using satellite data. Is it possible to do that? Maybe Professor Masati, you have. Yeah, can you explain about this, or Pak Ion? Please, Pak Masati.
Yeah, for sure. Dams deformation, it can be done by satellite, mainly with INSAR, especially if you're looking at small deformation. With satellite INSAR, advanced INSAR technologies, that is one of the technologies that we use strongly worldwide. We can detect measurement and deformation in the order of millimetric level precision, potentially in a few cases going also below this threshold, but that's more or less the average value. That's good for both rock, both concrete and our dams. There may be some issues sometimes if you have dams that with a lot of vegetations coverage that can limit a little bit. But apart from these cases, it's definitely something that can be done. And what is good is that when you do this type of analysis, also talking about cost, for example, the cost of doing for us only the dam or also the basins and the slopes is not so different. So potentially it makes sense to monitor not only the dam itself, but also the slopes surrounding in case they can be interesting or unstable.
Yeah, okay. Thank you. Yeah, this is possible, but we need more accurate and also take care about the noise from the data. Okay, maybe the last questions about this Pak, to address to Pak Ion Padilla related to your presentations. Is it based on just for each dam we conduct this modeling or monitoring, or can we do this as a like in general or as a basin level, or maybe for the whole dam that can also ensure the environmental quality for in the long term? Please, Pak Ion.
Yeah, so what we do is basically we allow our clients to choose how they, or which are the dams that they want us to monitor. And then you have a centralized system in which you can choose each dam, and then you can see these data variables per dam, and then obviously have the forecast per dam. And we can as well integrate this data that we produce through satellite data in other models, right? So we can offer our own water inflow model, or if you already have one, or if you work with another company, we can integrate this data in that model.
Okay. So but basically you apply this for each dam that has a specific features and analysis, yeah? Okay.
Yeah, and in terms of the long-term water, long-term forecasting, so basically what we can do as well, and we've done this with other clients, is that we can generate scenarios in which there are some variables that are changing. For example, with climate change. So let's say that we want to simulate what happens if we increase the temperature 1 or 2 degrees more, see how potentially the snow levels or the water levels in the soil, etc., change, and therefore how the discharge curve is going to be in our lakes, how it's going to be extended or reduced, and so on and so forth. This can be done as well.
Thank you, Pak. Okay, we are running out of time, but do we have last questions addressed to Professor Mazzarti related to the prediction of earthquake using this satellite data? Is it possible to do so, Pak? Please, Pak.
That's a very hard question. To be honest, I would say no. I think at present the prediction of earthquake is something that is very hard to do. There are few scientific papers presenting some back analysis on the, for example, pre-earthquake deformation at the large scale level that seems to be promising, but to be honest, as we are not in a scientific community here, but in a practical community, I would say we have to face with something that is not predictable right now. We can know where this happened, but we have already the knowledge independently from satellite. Maybe satellite can help to refine the mapping, but predict the time is something we are not ready for, unfortunately.
Yes, it's very difficult to predict these earthquakes. Okay, Pak, maybe that's the session 1. We are running out of time. We should move to the interesting session about the quiz. And thank you for all the panelists here, Pak Professor Paulo Mazzarti, Pak Marcelo Leite-Ribeiro, and Pak Ion Padilla, and Ibu Marta. And I give back this screen to Ibu Tara. Okay, thank you. Please, thank you very much.
Thank you very much, Pak Irfan, for the hosting the first session. That is very, very interesting session. Thank you very much, Pak Irfan Saleh, as the Director of Water Resource in Bappenas, the Ministry of Development Planning. And we also thank you to Mr. Paulo, Mr. Marcelo, Mr. Ion Padilla, and also Ibu Marta, which are no longer here with us, but we are very thankful for the inspiring stories, success stories, learning from this experience in other countries. And we hope that we could also adopt some of this technology in Indonesia. So let me get back to Bahasa so that we can be more interactive in the interactive sessions. Baik, Bapak Ibu sekalian, kita telah menikmati sesi pertama dan belajar banyak hal mengenai citra satelit dan pemanfaatannya, dari mulai pemanfaatan untuk monitoring longsor, gempa, dan penurunan serta penggunaan Damsat dan juga beberapa tools yang lainnya untuk dapat melakukan perencanaan untuk emergency planning. Juga disampaikan pemanfaatan HYPOS dan TETIS terkait dengan sediment analysis dan juga optimisasi untuk hydropower production serta improve forecasting. Selanjutnya kita akan beralih ke sesi interaktif sebelum waktu istirahat karena sebentar lagi sudah waktu asar, jadi kami ingin mengajak Bapak Ibu untuk secara singkat dapat mengikuti sesi interaktif kuis berhadiah. Jadi supaya tidak mengantuk Bapak Ibu karena ini sudah cukup lama diskusinya ya, sudah 2 jam lebih. Jadi mungkin sambil stretching kami ingin mengajak Bapak Ibu untuk kita sama-sama mengetahui bagaimana pemahaman Bapak Ibu mengenai keamanan bendungan. Dan di sini kami akan sharing screen untuk menampilkan pertanyaan yang akan disampaikan melalui Kahoot. Nah, Bapak Ibu akan bisa melihat, mohon tunggu sebentar. Kami akan sharing screen-nya sebentar lagi. Mohon ditunggu. Oke, baik. Mudah-mudahan Bapak Ibu sudah bisa melihat screen yang tampil di sini. Di sini Bapak Ibu dapat join ke dalam sesi interaktif melalui scanning QR code yang telah tersedia. Dan juga Bapak Ibu atau cara lain yaitu Bapak Ibu bisa connect ke www.kahoot.it kemudian dengan PIN yang terlampir di sini. Wah, kami sudah melihat banyak sekali user yang sudah bergabung. Memang agak sulit tadi melihat Bapak Ibu sekalian karena ternyata memang untuk video mode-nya ternyata turn off sehingga kami mudah-mudahan dapat diwakili oleh Bapak Ibu melalui emoticon-emoticon yang lucu di layar kaca kita. Di sini akan ada kuis berhadiah, nanti yang harapannya teman-teman bisa ikuti dan nanti juara 1 sampai 3 akan mendapatkan hadiah tersebut. Sudah ada peserta hingga 80 orang, kami sangat senang sekali karena ternyata teman-teman cukup exciting untuk mengikuti webinar ini. Semoga peserta dapat terus bertambah hingga mencapai 100. Kemudian kita bisa mulai acara kuisnya. Baik, peserta masih terus bertambah. Oke, kita akan segera mulai supaya mempersingkat waktu. Baik, semoga Bapak Ibu bisa mendengar suara yang ada di screen ini. Coba saya coba lagi ya. Oke, baik. Mari kita mulai sesi kuis. Jadi pertanyaan pertama merupakan pertanyaan testing. Kami ingin mengecek kepada Bapak Ibu apakah Bapak Ibu mengenal siapa nama football player yang ada di tampilan layar kaca kita. Teman-teman mungkin masih refresh dengan Football World Cup Championship yang belakangan ini sudah Coba kita tonton bersama. Oke, ternyata majority dari peserta menjawab betul, yaitu Lionel Messi. Dan ternyata ada beberapa yang menjawab Cristiano Ronaldo dan lain sebagainya. Jadi Bapak Ibu sudah dapat mengikuti acara dengan baik ya melalui menekan tombol sesuai dengan jawaban yang tepat. Baik, kita akan mulai question yang sebenarnya terkait dengan keamanan bendungan. Bapak Ibu silakan bersiap. Oke, scoringnya untuk yang pertama ada Bapak Sony, kemudian Dami, Rahma, Miyung, dan B. Oke, kita akan lanjutkan dengan pertanyaan yang sebenarnya. Oke, pertanyaannya adalah apa dari statement berikut ini yang tidak berkaitan langsung dengan dam safety? Yang pertama ada regular 5 years inspection, kapasitas faktor dari hydropower, reliable access terhadap dam site, dan juga huge number of fish catch in the reservoir. Oke, ternyata jawabannya adalah capacity factor of the hydropower. Jadi 3 di antara faktor yang lain masih terkait dengan keamanan bendungan ya. Jadi inspeksi secara reguler 5 tahun itu juga sangat penting untuk dilakukan. Akses terhadap situs bendungan itu sangat penting dalam rangka melakukan kegiatan perbaikan, rehabilitasi, dan operasi serta pemeliharaan. Dan juga kita perlu juga mengetahui berapa sih jumlah fish catch yang ada di reservoir untuk kita dapat memonitor dalam konteks kaitannya dengan polusi atau sedimentasi yang memungkinkan terjadi di dalam bendungan tersebut. Oke, kita lihat scoring board-nya. Yang pertama ada Bapak Warto dari BBWS PJ. Nah, ini, terima kasih nih. Ada 2 yang PJ itu. Apakah pengen Jenebrang atau Pemali Juwana nih? Kita kurang tahu ya. Tapi mungkin nanti pada saat scoring sudah menunjukkan pemenang kita bisa mengetahui. Baik, selanjutnya remotely sensed data are very useful for dam management because yang pertama, quick and readily available, requires skill staff to use it. Oke, jadi semua hampir kebanyakan dari peserta menjawab semua benar dan ternyata itu adalah jawaban yang benar. Congratulations. Masih ada beberapa yang menjawab jawaban lain, tetapi mari kita lihat scoring board-nya. Oke, ternyata Dani menyusul dan juga Febri dan Dodi. Nah, mudah-mudahan teman-teman yang lain juga bisa menyusul karena scoring board ini dilihat dari kecepatan serta ketepatan jawaban. Baik, kita lihat pertanyaan berikutnya. Oke. Komponen berikut ini dalam bendungan terkait dengan keamanan, kecuali yang pertama spillway, yang kedua finage, 3 volume reservoir, dan juga piezometer. Nah, kira-kira mana ini Bapak Ibu yang merupakan jawaban yang tepat? Baik, jawaban yang tepat adalah warna biru, yaitu volume of reservoir, dan majority dari peserta menjawab dengan benar, yaitu volume reservoir. Jadi berikut ini adalah volume reservoir ini sangat ini adalah yang tidak termasuk di dalam komponen safety bendungan, tetapi ini adalah bagian dari informasi teknis dari bendungan atau karakteristik dari bendungan, yaitu volume, kemudian tinggi dan sebagainya. Mari kita lihat scoring board-nya. Yang pertama unggul ada Red, kemudian disusul dengan Dodi yang naik ke klasemen 2 dan juga Febri. Kita lihat lagi di pertanyaan berikutnya, siapa yang akan memimpin. Oke. Lifetime dari reservoir depends on the following factor. Jadi usia dari bendungan itu tergantung dari berbagai faktor ini, kecuali apa? Apakah sediment management, diligent maintenance, condition of catchment, atau KBLR? Waktunya 30 detik. Semoga Bapak Ibu dapat menjawabnya dengan benar. Oke, majority of participants answered correctly dengan jawaban automatic water level recording. Jadi yang mempengaruhi usia bendungan termasuk diantaranya adalah sedimen management, pemeliharaan yang rutin, dan juga kondisi dari das yang tentunya akan berkontribusi terhadap sedimen yang masuk ke dalam bendungan, dan juga jumlah ketersediaan air yang masuk ke dalam bendungan. Baik, kita lihat scoring board yang memimpin masih dengan red dengan skor 3.250 dan disusul dengan Febri dan Dodi. Nah, Dodi merupakan juara 3 bertahan dan red juga juara bertahan. Febri menyusul di juara kedua. Oke, pertanyaan selanjutnya, manakah yang tidak tepat dalam statement berikut ini? Community participation could contribute to the safety of the dam. A dam is responsible to generate revenue. Function of the dam highly depend on the equate island budget. Atau all statements are correct. Oke, ternyata jawaban yang benar adalah all statements are correct. Jadi semuanya benar dan kebanyakan dari peserta menjawab dengan tepat. Baik, kita lihat scoring boardnya lagi. Oke, Febri menyusul naik ke peringkat 1, disusul dengan Dodi, dan juga Dian Arif yang merupakan juara ketiga yang baru. Oke, masih ada satu pertanyaan lagi. Bendungan berkontribusi terhadap lingkungan, dampak lingkungan, kecuali apa? Yang pertama ada greenhouse gas, groundwater, river regime, atau navigation. Oh ya, jadi gambar yang tadi kami tampilkan sebelumnya merupakan community participation yang telah dilaksanakan di kegiatan DOIS di Batu Jaya. Baik, jadi majority dari peserta menyampaikan navigation. Nah, ini mungkin agak sedikit dilematis juga, tapi di sini yang dipertimbangkan mungkin adalah groundwater atau air tanah. Mungkin ini juga bisa menjadi apa ya, suatu pemikiran yang lebih baik dari diri kita, apakah betul-betul navigasi itu akan berpengaruh atau groundwater. Mungkin nanti ini mungkin hal yang bisa diperdebatkan, tetapi bisa menjadi masukan untuk kedepannya. Oke, kita lihat. Jadi, kita sudah selesai dengan kuisnya, seluruh jawaban. Juara ketiga diraih oleh Dian Arif, yang kedua oleh Dodi, dan yang terakhir, juara 1 adalah Febri dengan skor 3.956. Dengan saudara Febri, kami mohon untuk dapat menyampaikan sedikit pesannya mungkin di sini saudara Febri apakah dapat menyampaikan kira-kira username-nya siapa, mungkin nanti bisa berkontak dengan teman-teman peserta supaya nanti dapat kami hubungi untuk hadiahnya. Jadi hadiah dari prize kita kali ini yaitu adalah buku. Mungkin kami akan sharing sedikit bukunya seperti apa. Jadi para pemenang akan mendapatkan buku berikut ini. Jadi ini adalah buku-buku knowledge product yang telah dikembangkan Bank Dunia bersama dengan Kementerian PUPR dan juga Bappenas. Yang pertama ada buku Water Security Report yang telah dikerjakan selama beberapa tahun belakangan yang mencakup tentang berbagai macam informasi tentang water security di Indonesia. Ada buku Maturity Matrix yang mungkin teman-teman balai juga sudah cukup familiar. Dan juga ada satu buku baru yaitu Good Practice Note on Dam Safety. Yang ini nanti akan kami bagikan secara hard copy kepada teman-teman yang meraih juara 1, 2, dan 3. Mungkin bukunya tidak dapat terlihat di layar, tetapi bukunya sudah ada bersama kami. Jadi nanti akan kami kirimkan kepada peserta yang menerima juara 1, 2, dan 3. Nah, Good Practice Note on Dam Safety ini buku yang telah di-launch di tahun 2020 oleh Global Solution Group Bank Dunia yang mengedepankan berbagai aspek terkait dam safety, khususnya untuk bagaimana kita menghitung risiko bendungan, keamanan bendungan, bagaimana kita memperhatikan environmental safety atau environmental safeguard dari bendungan, dan juga berbagai macam guideline untuk praktis dam safety di seluruh dunia. Jadi mungkin ini adalah suatu kerangka yang dapat dipakai oleh teman-teman untuk memberikan masukan dalam kelanjutan pelaksanaan maupun dalam upaya operasi dan pemeliharaan bendungan di Indonesia. Baik, mungkin sesi question and answer interaktif sessionnya sudah selesai. Kami ucapkan selamat bagi Bapak Ibu yang telah memenangkan kuis ini di juara 1, 2, dan 3, dan harapannya nanti teman-teman yang lain tentunya juga dapat mendownload dokumen knowledge product ini dari soft copy-nya melalui link yang telah kami berikan sebelumnya, dan nanti juga bisa ditanyakan kepada panitia jika ada pertanyaan untuk akses terhadap link knowledge product tersebut. Baik Bapak Ibu, supaya tidak berlama-lama, kita berikan waktu untuk istirahat selama 15 menit, kurang lebih mungkin kita bisa kembali lagi di jam 3.35, sehingga Bapak Ibu ada waktu yang cukup untuk istirahat. Baik, terima kasih Bapak Ibu, kami ucapkan Assalamualaikum warahmatullahi wabarakatuh, selamat beristirahat dan beribadah. Sampai ketemu lagi di jam 3.15. Terima kasih.
Hi, Tara. This is Raj.
Hello, Raj.
Can you see my video? Can you see me?
No.
We cannot see you yet.
Okay, I'll use the another one.
Or...
Yeah, there's something, when I try to put on your background, I think I did something mistake. So I will use, I'll use another.
Maybe you can remove the background if it's too difficult, that's okay.
So I'll come from here. Yeah.
Okay.
Hi, Professor Kaiko. Good to meet you.
Yes, nice to meet you. And thank you very much for your invitation to this meeting, and also your preparation, our visit to India, Kerala.
Sir, you're most welcome. Almost everything has been prepared. So I think, unfortunately, we cannot get the data, but let us first demonstrate, and then we can take it from there.
Yes.
So, Tara, we are working with Professor Kaiko under DRIP for integrated cascading reservoir operation.
Oh, wonderful! So that will be the DRIP 3.
DRIP 2. That is what we are doing.
Oh, the DRIP 2. Oh, okay. So So we're happy to know that you have been in a close collaboration, Professor Kaiko, with Raj on the DRIP project. We hope that in the future we can work with you too in Indonesia.
And
hello, Professor Kaiko. Nice from the young here. Okay. Thank you for joining, Professor. Very happy very happy and very excited about your presentation. So look forward to that. And also happy to see Raj there. I hope all is well, Raj.
Everything good. Professor Kaiko and the iCharm and JWA team are visiting Kerala on the 23rd, 24th, 25th for a workshop on cascading dam integrated reservoir operation. So we want to help the Kerala team after the flood. So we are working with them together on that.
Yeah, I remember that. Yeah, and that's a very important issue in Indonesia also. Where one of the things that is happening in Indonesia is the government of Indonesia is investing big time in new dams, and as you know, as there are already existing dams in some of these basins, you get into a situation where these dams will be part of a cascade and need to be managed as being part of a cascade and not on a standalone basis, which makes a big difference.
Yeah, actually, I have been working with the government of Indonesia and the PUPR mainly, and I worked in several areas in Indonesia, and but at this moment, we are now I'm introducing our dam operation optimization system. Today, I would focus on single dam operation. As you mentioned, the cascade dam operation is also very important task in our group.
So, Iceman, as we develop and understand through Professor Kaiko in Kerala, we will transfer our understanding to Indonesia also. It's all one big team from the bank side.
Exactly.
So,
I look forward to that. No, it is so. You know, this is expected to become a topic in a follow-on investment operation if the government of Indonesia is interested. But cascade management, cascade operations of cascades of dams is a very important thing because I think we saw it also in India. Some of the dams we visited in India, even if they are part of a cascade, they continue to be operated on a standalone basis. Also because some of the dams are operated by different organizations, and so it complicates matters tremendously. But the benefits of cascade management as opposed to standalone management are also very significant.
Yeah. So things has little bit changed, Icebrand, like in 2021, as per the Dam Safety Act, they need to now have the integration reservoir operation. Earlier, we don't have any policy binding the different agencies, and especially when it is a two-state dam, they don't share data. But with the Dam Safety Bill in force now, they are bound to do it.
That's also a very interesting element in that we can learn from India. The Dam Safety Act is really a very important tool to achieve many of the dam safety issues. So maybe also something we can learn from India.
No, Icebrand, I think at some point we need to discuss is the good part for India, Vietnam, Indonesia is that we already have an operation, right? So what we did in India is that whatever element is coming in the Dam Safety Act requirement, that we have demonstrated under the project. Because with various states coming in, there's always a debate like emergency action plan. Some states says it is required, some says we are not required. But under the DRIP 1, we demonstrated for 198 dams. So everybody is a common platform. So at least we have something to demonstrate. So we only talk about policy on papers. Sometimes it's difficult to convince the entire country. So when we have a project like what you have there, we can demonstrate in the ground what it really means in the policy. So that really help us in India.
Yeah, exactly. There is nothing better than learning by doing.
Exactly.
By practical experience, and that is that you can't compete with that.
Yeah. So we should take advantage of the existing operation in Indonesia in framing the policy slowly but steadily, and by demonstrating. I'm sure when we put any requirement on the Dam Safety Act, people will have inquiry like whether it is possible, how can we do. So we have the project, how is to be done, we demonstrate there.
Yeah, last week I visited the bank in Washington, D.C. And I met the new global director, the water global practice, the Mr. Saroj Kumar Jha. And I invited him to the next the sixth UN water sixth UN special the thematic session on water and disaster. It will be held on March 21st, just before the UN Water Conference in New York.
So Icebrand, how is the format? Sorry, I wasn't in the earlier session. Do we have to share the screen, or somebody is centrally doing that?
In my case, I would share my screen by myself.
Okay, perfect. So then I will do the same also.
I think you have a choice, provided that your internet connection is good enough, which is the case. So.
Yes,
so that's good. Go ahead and share your screen, and you can flip through the slides yourself.
Yes, Pak Raj and Professor Koike, if you prefer to share your own screen, that's fine with us. If you want us to help you sharing the screen, it's also possible. So just let me know which one is more convenient for you.
For me, let me try sharing it, whether it works or not. Okay. Sometimes it complicates things.
Yeah.
Can you see my screen?
Yes, we can see.
Yeah, we can see your screen. And please don't forget to put it in presentation mode. Huh?
Yes. Is that good?
Yes, this looks good, Pa. Yeah.
Perfect.
That's great. Yes. Wonderful. So Pak Raj, you asked before about the rundown of the session. So for the next session, the Pak Edwin Alexander will be the moderator of the session. And then the presentation consists of 4 speakers. The first one is Professor Koike, and then continue with your presentation. And then continue with Professor Janus. And ultimately, we will have Dr. Neil Andika as well to present on the Indonesian perspective. So you will be on the second speaker session, Pak Raj.
Perfect.
Yeah.
So
can you see my screen now?
Oh yeah, we can see your screen. Excellent.
Okay, thank you.
Professor Koike, thank you so much.
So Icebrand, my presentation is what you advise. I try to put in something on the institution, a little bit linking it to Dam Safety Act, and also on what parameters that Government of India is monitoring for the safety. So I'm breaking into those pieces.
Yeah, great. Look forward to your presentation, Raj.
But one thing we want to iterate is that remote sensing monitoring is good, but when it comes to dam safety, physical foot in the ground is very important.
Yeah, exactly. No, I think that's one of the recommendations that other people also made. So remote sensing is not to replace a human action. It's in addition to human action. It supports human action. It cannot substitute for that.
Complement.
Yeah, it should complement. But see, when something happens, the early signs are eventually noticed by our dam engineers by physical inspections. Yeah. So what remote sensing says is a little bit at a later stage where things have been already harmed, right?
Yeah, it's tempting to make that argument because the argument is that so many of these dams are located in very remote places, and then the next thing you say, is okay, you know what? Let's just don't worry about visiting these dams in person, but just let's do everything through remote sensing. And that is something that is not correct. Even if they are remote, you still need to visit them in person.
Yeah, we do in Kerala in some remote. We even put surveillance like video cameras and all, and we have a center. But we ensure that because these are in the very remote areas where they have a lot of elephants and tigers and all. So, so we do keep video cameras, but we ensure we under the project we develop fencings and quarters so that at least a team is there on site all 24/7.
Yeah. Yeah, they have that here too. Yeah, they have a very sophisticated high-tech nerve center of dam safety where they collect all the video feeds from the different dams. Looks very impressive.
Yeah. Good. I think you have a lot of participants, Tara and Icebrand. Congratulations! More than 300 people participated.
Yeah. And then there are people on YouTube that follow that are not included in this count.
Okay.
So well over 300. Yeah.
Yeah. Usually when we have influential people as well in the previous webinar series, we could reach up to more than 500. And also, actually, we have 1,000, yeah, Pak Iswan, last time.
Yeah, I think the first one we had 1,000 participants. Yeah.
Okay.
It was for with the governor. Yeah, Pak Iswan. The governor is very popular. Of the governor of Bandung, so he was our main speaker at that time, and people were very interested because he's concerned about water, and he helped in managing the water pollution in Citarum River Basin, one of the considerably dirtiest river in the world, they say. So maybe with India we have also similar issues on the pollution as well that we could learn from you. Like from we heard from Ganga project, you will have like river cleanup as well. I think those are.
You have our TTL of Ganga Icebrand sitting over there.
Yeah, ex-TTL. But Raj is coming to Indonesia in February, and we're going to organize a workshop. And we are preparing a draft program. And one of the things that the government of Indonesia is very much interested in is precisely river cleanup, river basin management. And so I have penciled you in for a presentation on that topic, but it's still very preliminary, so don't block the time yet. But if the time is there, then maybe we get back to you.
Yeah, do let me know. February is little tied up. We have a team visiting Hoover Dam and Oroville Dam from the government of India. So they will visit 1 week before the Water Week, and they will join the Water Week. So, but before that, I'm okay with that.
Yeah. Okay. Yeah, it will be well before that. Water Week is starting February 27th, I think, and so Saroj's visit is on February 9 or so, to be confirmed.
Yeah, that should.
Okay. I think we're about to resume.
Sorry.
Selamat siang Bapak Ibu sekalian. Terima kasih sudah bergabung kembali ke dalam acara webinar Dam Safety from Space. Semoga Bapak Ibu telah beristirahat sejenak dan juga ada waktu untuk beribadah dan sholat. Mohon maaf waktunya sangat singkat karena memang jadwal kita sangat padat hari ini. Kita masih ada satu sesi lagi, yaitu sesi kedua yang tentunya tidak kalah menarik, diisi dengan berbagai macam cerita dari para speaker yang inspirasional yang harapannya nanti akan dapat memberikan pembelajaran yang menarik bagi kita semua terkait dengan keamanan bendungan dan juga operasi serta pemeliharaan bendungan. Baik, sebelum kita memulai acara, mungkin sedikit housekeeping information. Kami telah sharing di dalam screen di chat box link terhadap materi webinar. Memang di sini materinya itu ditampilkan sesi kedua, tapi jika Bapak Ibu cek backwards ke folder sebelumnya akan bisa akses ke webinar secara keseluruhan. Namun kami akan mengirim lagi sharing materialnya. Jika masih ada trouble mungkin nanti akan kami perbaiki dan kami reshare untuk materinya. Tersedia channel interpretation untuk mendengarkan dalam bahasa Indonesia maupun bahasa Inggris. Nanti para speaker akan mempresentasikan sesuai dengan bahasa masing-masing, sehingga silakan Bapak Ibu mendengarkan sesuai dengan pilihan channel bahasa yang diinginkan. Baik, mungkin tidak berlama lagi, kita akan melanjutkan ke sesi kedua. Sebelumnya, Assalamualaikum warahmatullahi wabarakatuh. Selamat sore, salam sejahtera bagi kita semua. Om Swastiastu, Namo Buddhaya, salam kebajikan. Di sesi kedua kali ini, kita akan membahas topik, yaitu sharing good practices in improving dam safety and operation, di mana berbagai narasumber akan berbagi pengalaman mengenai praktik-praktik yang baik dalam upaya meningkatkan keamanan serta operasi dan pemeliharaan bendungan dan juga sungai di berbagai negara dan juga di Indonesia. Sesi kedua ini akan dipandu oleh Bapak Edwin Alexander selaku moderator sesi kedua. Beliau adalah perwakilan dari Direktorat Bina Operasi dan Pemeliharaan yang secara aktif terlibat di dalam proyek Dam Operational Improvement and Safety Project atau DOIS. Baik, untuk mempersingkat waktu, kepada yang terhormat Bapak Edwin Alexander, waktu dan tempat kami persilakan. Sebelumnya kami akan menginformasikan kepada teman-teman peserta bahwa jika ada pertanyaan kepada para speaker dapat disampaikan melalui Q&A channel yang tersedia di bagian bawah, sehingga nanti pada saat Q&A dapat kita diskusikan bersama. Baik, mohon maaf sebelumnya kepada yang terhormat Bapak Edwin Alexander, waktu dan tempat kami persilahkan.
Terima kasih Mbak Tara Sugeng Enjang. Assalamualaikum warahmatullahi wabarakatuh. Bismillah, kita akan segera memulai sesi kedua. Saya akan coba memandu dalam bahasa Inggris. Good afternoon, ladies and gentlemen. My name is Edwin Alexander from Directorate of Operation and Maintenance, serving as your moderator for the second session. This second session is sharing for international practices in improve dam safety and operation. And as Mbak Tara said before, please feel free to have a question in Bahasa. In this session, we're going to discuss about new cutting-edge technology related to the dam management, especially to improve inflow forecasting accuracy related to dam management, include operation, monitoring, and maintenance. Of course, one of our goals is to have a predictive maintenance in the next future, keeping the outcome for our dam and meet the demand on the downstream one. Our National Hydroclimate and Geophysics Agency is already issued a 2023 climate outlook that predict that in 2023 there are no influence from El Nino, Southern Oscillation, ENSO, or El Nino, and also Indian Dipole Ocean. And also, it means that we are on the neutral phase next year, but the annual precipitation is predicted to be above normal, so there are potential hydrometeorology-related disaster. So it means that the forecasting accuracy is very critical for us to allow to mitigate earlier and to have a better operation in infrastructure, both in wet and the dry season. The utilization of artificial intelligence, as mentioned in the previous session, machine learning and deep learning, as Pak Ion already explained on the previous session, is very valuable information and knowledge for us. We are on the same direction there. And as the Google Machine Learning Handbook rule number 1 already said that if you can build a simple rule-based system that doesn't require machine learning, so do that. So it means that hopefully we can compare several methods in seeking the best result to improve our accuracy in forecasting. Without further ado, here now is Professor Koike, Executive Director on International Center for Water Hazard and Risk Management. Professor Koike won global recognition for his dedication, 149 published papers and dozens of honors and awards already achieved by him. And Professor Koike is going to speak about inflow forecasting that allows the uncertainty in the forecast to be assessed quantitatively, and attaching number to the confidence of the uncertainty can also allow the user to use to assess the risk more accurately. So, Professor Koike, do you read me?
Thank you very much, Edwin. It is my great pleasure to introduce the recent development, the technology which has been already used in Japan with the Indonesian expert and all over the world. And as Edwin introduced, we try to respond to the basic needs and the function for dam safety and maximizing the dam the function. So for that purpose, we need to consider 3 components. We need to address the short lead time issue. And also, we need to consider water use and the flood control both. And real-time the management, data management, operation support is critically important. To address these 3, we introduced the quantitative precipitation forecast, QPF, considering uncertainty. Yeah, precipitation forecast includes uncertainty, but quantifying the uncertainty, we will try to make a maximum use of this information to address a short lead time. With regard to the water use and flood control both, we introduced the water and energy budget hydrological simulation system, which can cover from low flow to high flow in a seamless way. And also the dam operation rules for effective pre-release and infallible the water storing to increase capacity for flood control and water use, respectively. And with regard to the real-time data management and operation support, this data integration and information fusion system, the so-called data data integration analysis system, DIAS, which has been developed in Japan, Japanese science and technology community. We are now introducing this system. So the system consists of the runoff simulation system by using the observed, just a moment. Yeah, observed the river discharge and also the basic information of the topography and land use, etc., and the hydrometeor data from satellite and in-situ observation. And we use the water and energy budget simulation. That's why we need various meteorological data those data can be provided by the hydrometeorological reanalysis system. This is a global data set. That's why we can apply this system all over the world. And by using these information as an input, we learn the water energy budget, distributed hydrological model, and the rainfall runoff inundation model. We have two systems. And this system, they consist of the energy and water flux balance, and also the soil moisture and lateral flow, this slope flow, and also the plain, the inundation in the plain, and also the river flow. So these four components are integrated. And in addition, we have a rice production model, dynamic vegetation model. In a snowy region, we have a snow and glacier model. And this can be connected with dam operation and irrigation system. And in addition, we coupled the inundation monitoring system with this system. So based on these two the hydrometeorological simulation system as we used as a basic the component of this system. And this system can be calibrated, validated by river discharge, and also the inundation area observed from satellite. The visible infrared data and the active microwave data can be merged, and then even the cloudy condition, we can monitor the flood and the inundation area continuously. This is the example of the application to the West Africa. And with regard to the quantitative precipitation forecast, we use the ensemble rainfall prediction system based on the global operational GCM weather forecast system of Japan, US, and the European community. And by applying the globally observed data, we downscale, and also by introducing the perturbation, we have ensemble prediction with a high spatial resolution with 5 kilometers. So this is the rainfall prediction system. So this system is coupled, and then we can have an ensemble runoff prediction system, runoff prediction in a reservoir. And this information is coupled with the basic information of the dam operation, and then the optimized dam operation is applied, and how much dam release in advance, or how much use for water, use for hydropower. This kind of the system has been developed. So the basic dam operation should be designed the responding to the needs of each reservoir. In this case, we discussed with hydroelectric company of Japan, and based on their need of the hydropower and flood control, we made a design of the basic rule for flood control and for hydropower. And we checked the inflow by inflow and accumulated inflow based on the forecasting the forecast, and then based on this forecast, if the inflow exceeds the designated amount of the inflow, the flux and accumulated value, we release the water in advance. If not exceed, we use water for power generation. So this is just the example for the case in one dam in the reservoir. And then we can provide the information of the ensemble runoff and inundation in the downstream. This whole system is being operated by data integration analysis system. This system was developed to create knowledge enabling us to solve the Earth environment problem and to generate socioeconomic benefit. Led by the University of Tokyo and also the support from Ministry of Education, Culture, Sports and Technology of Japan, MEX Japan. So the various data and information are integrated and coupled with the geophysical information and also the dictionary of the various discipline. And then this system has a very huge capacity of the data storage, more than 100 petabytes. So all of the related data are now being archived in real-time basis. So we are now using this system. And this system was applied to the one reservoir for hydropower, which is operated by the one electric company in Japan. And this is really mountainous area. This is the result of the application of this system from July to October in 2018. And we had a very serious flood from September to October. And this is the result of our ensemble prediction. The blue one is the observed one, and color line shows the ensemble prediction from the top 3rd to the 29th. Actually, we have 32 the ensemble prediction. This is another case. Next year, the 2019, we also have a very serious flood in October. And in this case, our ensemble prediction this is 39-hour prediction. The prediction with 39-hour lead time, and this case we have the overestimate, but we have a very good timing of the prediction of the flood. So by using these information, 39-hour lead time information, this is a case of the 2018. In this case, the reservoir, originally reservoir almost full. This blue line is the safe water use level, and red dash line the full reservoir level. So this dash, the black dash line shows originally it is almost full. So then, based on the prediction, this operation system suggests the release in advance, as shown in the pink color, and the reservoir level is decreased, and keep the capacity for flood control, and flood come. And this blue line is the inflow, actual inflow into the reservoir. This red dash line shows the 39-hour prediction of the inflow. And based on this operation, this information, reservoir stores the water very effectively. And this orange color is actual dam release, but we can keep the dam release maximum value is 600 cubic meter per hour. So this is the case of the 2018. In 2019, in contrast, the initial reservoir level is very low, much lower than the safe water use level. So that's why this system suggests we don't need to release in advance. And actually, the flood come. Even though the 39-hour prediction is overestimated, but we can keep the inflow very effectively and it reached the almost maximum, and we can keep the high water level after the event, and maximum discharge also the 600 cubic meter per second. This 600 cubic meter per second is designed the value for safe release. So in addition, this system was operated from July to October continuously. Then we can increase the hydropower 12.8% in 2018 case and 4.3% in 2019 case. So in this way, the rainfall observation, the monitoring system, and water and energy based hydrological model, and inundation area assessment by satellite, and advanced rainfall prediction system, and optimization reservoir operation. And this system consists, and this system is introduced to the Japan. Actually, to the river basin. In the two river basin, this system is now being operated. So, in addition, this is a really brief introduction to the system, but this system was developed by DIAS. That's why system design demonstration test operation can be integrated in a targeted area by using this system. And also the capacity building for system use, almost 1 month short course training we need. And if you need to apply the system by yourself and maintain by yourself, 1 year master course may be necessary. And also the advanced system development research, the 3-year PhD course may be reasonable. So with regard to the operational system development, we are very happy to cooperate with Japan Water Agency, JWA. So so in this way, we will be able to contribute to the user. So this is our system. And finally, I would introduce one good news. We had a 4th Asia Pacific Water Summit in Kumamoto in April this year, and 18 head of state and government, they joined. Your president also joined in the video, and PUPR Minister Basuki, they joined in person in this meeting. And Kumamoto Declaration, the chair summary focusing on science and technology were adopted. And our Prime Minister, Mr. Kishida, announced the Kumamoto Initiative for Water, in which he emphasized the effective use of the existing dam by using the forecast and satellite observation. So, and he also emphasized the capacity building, the opportunity based on the DIAS, and he promised the financial assistance, 5 billion Japanese yen for next 5 years. This is our Prime Minister announcement. Thank you very much for your attention.
Thank you very much, Pak Koike, for your presentation. So in conclusion, in order to address the 3 main issues you mentioned before, we have to use data integration. So I know the 3 critical issues regarding data integration. First of all is data availability, and the second one is quantitative analysis, and the third one is validation and calibration to the ground observation data. And later on, maybe the participant will also interested in how to manage early release on the dam operation before the flood is coming, as is shown on the slide 18. But be patient, gentlemen, so we still have Q&A session. Maybe we can have like 1,000 questions to Prof. Koike so we can learn from him. So up next, we have Mr. Rabungham Rajagopal Singh, Senior Water Resource Management Specialist from World Bank, and Mr. Singh is going to speak about dam monitoring establishment and monitoring cascade operation. For your information, Mr. Singh, we also have a dam monitoring unit, so maybe you can share knowledge with us, and so we can learn from India and how you manage the dam in India. So the screen is yours, sir.
Thank you, Erwin. Can you see my presentation?
Yes, sir.
Thank you. Thank you to the organizing team, especially my colleagues in the World Bank. It's amazing to see a workshop where more than 300 people are attending. So it shows the sheer quantum of the interest in dam safety, especially in Indonesia. I will talk a little bit about, before jumping into what India has done so far, let me give a brief background of the sheer number of dams in India. So as per the ICOL bulletin, there are 5,700 large dams in India next to China, US. And I understand as per the ICOL, there is a good number of large dams in Indonesia. So we share the same concern. But at the same time, it may be looked at that India as well as other countries has been pushing a lot of infrastructure, dam infrastructure, which has become the backbone of their economy. However, many of these dams, 300 dams out of 5,700 dams, are more than 100 years old. So what India has been facing is very similar to any country who has large infrastructures. So there has been a idea of, let's build more dam, but the focus was not on the management. So it leads to deferred maintenance and deterioration. Insufficient funds have been allocated to manage these dams. In addition, I think Professor Koike also mentioned, and Elvin also mentioned, inadequate capacity of dam engineers and the weak institutions. So this is not only about India. I think this is a generic issue that all countries which has large dam infrastructure face. So this was the challenge which India faced. However, India looked at their 5,700 dam as an opportunity and as an area where it becomes the backbone of the economy. So they have been investing a lot in the last 30 years. Bank has been engaged with India over the last 30 years. From an India perspective, dam safety, of course, they want to secure the dam from a disaster perspective, but they are also looking dam from a water security perspective with the climate change scenario coming into it. So we started working with Government of India, the World Bank, way back in 1991, and still we are continuing it. So today I will talk a little bit about the Dam Rehabilitation and Improvement Project, DRIP 1. We have run this project over the period of around about 10 years. So it supported 7 states, rehabilitated 223 dams, and an investment of around about $300 million from India. Based on the successful completion of that project in 2021, a dam safety bill was enacted, and we have been requested by the Government of India for 2 follow-up projects on the same project, DRIP 2 and DRIP 3, which is a pan-India scale now. So just to highlight some of the work done under DRIP 1, so physical rehabilitation, the first component is the rehabilitation part. It has 2 components. One, we talk about the physical rehabilitation, and the second, we talk about the non-structural intervention. In physical intervention, nothing much. It's a very known to any dam engineer, grouting, repair, hydromechanical gates, everything. But what we try to do is try to introduce some new technology, like geomembrane, like underwater drone for surveying the gates and the structures. So those kind of things have been introduced in 198 dams. In addition to that, we try to look at dam safety from a holistic perspective. So if the dam body is secured also, we try to look at the approach road. So for example, if the approach road is not there, if something happens to the dam, how do we reach it? So approach roads become very important and become a parcel of the structural stability. the power backup, security facilities. So all are being looked at a holistic perspective, because we have been looking into many dam safety aspects. We talk about the hydrological, the structural, and the operational safety, but we try to look at the other, basic facilities like approach road and others. So these are some, before and after picture. I'll not go much into the details. I think I'll be sharing the presentation, and you can have a look at it afterwards. The non-structural measure also is a very interesting and a very what I call critical component, which is not very costly, but which is also very important. So the foremost important is that many of these dams are more than 50-year-old, but the design hydrology with the latest climate change scenario has not been estimated. So revising the design flood is very important, and that is the first foremost point. Second, we try to look at dam break analysis, inundation map, emergency action plan, revising the operation and maintenance manual, providing instrumentation, and what Professor Koike talked about, info forecasting and flood routing. So these are some of the non-structural measures that has been carried out. Institutional strengthening is also a very important component. Many guidelines have been published. I will talk about that later. 186 trainings covering around about 5,000 participants are being completed. But our learning from DRIP is that maybe a 1 week, 2 week training programs are not adequate. Dam need specialization for their management. A 1 week training program introduced the issues about the project or the challenges they face, but they are not able to find solutions. So now going ahead, what we have done is we have tied up with 2 local universities, and for the first time in the world, a master's specifically in dam safety has been introduced from last year. So 60 students will be going for a master's program on dam safety, out of which 30 will be the students coming from outside, but 30 are being sponsored under the project for the existing government officials. So this is our learning on capacity building. Second, we try to look at a collaboration with international institute like USBR, JWA, now ICHAM. We are working on them. And the third is we are on a project mode. We try to inbuild a culture of project management. Many areas we have been working in the bank, the project goes in a different direction, is where we don't look much critically in the project management. So project management has been taken into good emphasize under the project. So let me talk about the institution that we have developed for the project. So we have looked at the project not as a simple project, but try to build a national strategy for the dam safety. So when we try to develop the project management unit, we didn't try to develop as a standalone institution. If you look at on the left side, that is the federal government. So we have the government structure, and the one circle in the red are the institutions that we have developed under the project. So these project management units are inbuilt into the government system. And if you look at the right, these are an example of a dam owning unit from the state government. So we try to use the existing institution and inbuild the project management unit into that so that it becomes part of the system rather than just a project mode. So for every project management, this is a sort of a template that everybody should have it. For example, a particular Tamil Nadu, which is having around about 98 dam under rehabilitation, has more, 54 staff. Some might have 30 staff, but these are the areas, the expertise they need to have. I think one of the earliest speaker talked about dam management is a multidisciplinary approach. So just a civil engineer is not enough to manage the dam. So we need to have expertise from every area. What we learn is, for emergency action plan, we need to have a communication expert within the team who can communicate what the engineers are doing to the layman's language. So these are some of the learnings that we have been having, and we need to inbuild in the system or the institutions. there has been a thorough monitoring of the project, though the efficiency of the institution that we develop has to be monitored, and we have a very robust monitoring mechanism. At the technical level, we have 3 levels of monitoring. We have QA/QC of the work happening every quarterly. Social environment compliances have been monitored quarterly. The result framework of the project are monitored twice a year. At the project level, technical committee developed by the Ministry of Government of India is done on quarterly basis. Bank also monitor it. So if you can look at this, is the level of monitoring that has been put into place to ensure the system and the project are in function. One of the critical aspects is that we really work in finding solutions, and we bid out in terms of civil contracts. But the most important is the execution of what has been defined in the bid documents. So there is a robust QA/QC mechanism, 3-tier mechanism. One is done at the dam level by the contractor himself. Second is done at the state level by their own system. And third is done at the federal level by the Ministry of Water Resources. And there is a 4th level which we haven't put in, which is done by the World Bank. So this is the level of QA/QC monitoring that has been put into place. Now in 2021, a Dam Safety Act has been enacted by the Government of India, and whatever institution that has been put in the project mode has now become part of the government system. So what has been developed as a federal project management unit has become the National Dam Safety Authority. The project management unit that has been developed under the project has now become the Dam Safety Unit at the states. So what we have been working is that we don't want to work on a project mode, but inculcate the culture in the government system itself. So whatever capacity we have been developing for last 10 years now has been absorbed in the government system through the Dam Safety Act. Going into a detail about the topic is on dam safety monitoring. These are some of the parameters under the Dam Safety Act that government has enacted in India. They are monitoring. The first is they want to look at all 5,700 dams. What is the revised hydrology? With the current climate change happening, what is the inflow? What has been the change? Do they have the adequate spillway capacity to cater to the revised inflow? That has been one of the things they have been monitoring. In addition to that, they are looking at real-time monitoring of hydrometeorological parameters and also the structural parameters. So here also we try to approach not as a project mode, but as a national project where we try to develop guidelines, national guidelines. So if you look at the left one, it is about how a hydrology revision will be done. So once a guideline is developed, that guideline is followed all across 222 dams and now across all 5,700 dams. Then we develop on instrumentation. We develop national guidelines for dam instrumentation on large dam. Once the guidelines is developed, the big issue is how do we roll out? So for example, a state of Karnataka has 256 dams. How do they roll out? They need to have a strategy for rolling out the instrumentation. Do they have one dam separate, 2 dams separate, or a group of dams? Because everything needs to be coming to one center and everything needs to be standardized. So we develop a technical specification so that one data of one dam is comparable to the one data of another dam. So we develop technical specification for all the instrumentation so that we are in the same standardization across India. And that has been implemented across all 223 dams. The second is the revision of the operation and maintenance manual, because some dams that are around about 50-year-old, the objective of the dam was separate. May it be hydropower, now it has become multi-purpose. It has irrigation demands to it, hydropower demand is already there, drinking water. So the O&M manual needs to be, revised, and that also to have a standardization across India, a guideline has been developed, and accordingly to that, things have been implemented. There is also before the monsoon, there is a annual review, annual inspection of all the dams. Again, a guideline has been published, and also we look at the accessibility and communication. And that is where the topic today, the satellite, becomes very important. When we talk about communication, what we learn is there are 2-3 ways of communication. One is the normal telephone landlines we have. The second is the GSM, the mobile communication. Third is the satellite. When any flood or any disaster happen, they first knock out the cell phone tower system and the landline system. So the most reliable communication system available is the satellite communication. So we have been developing all the real-time data communication from the dam for instrumentation through satellite communication, and also we inbuilt satellite communication system to its dam also. So these are some of the learning that we have. The third and the last and the foremost important is the emergency action plan. Again, national guidelines was prepared, EAP was prepared for 185 dams. And the most important is these plans are not being put in cover. They are being put to stakeholder consultation, and these have been implemented. The big issue that we are talking here is about the cascading dam. And India is also equally complicated like Indonesia, where you have transboundary within the country. And also many dams are owned by various agencies. So at present, what we have done is we have individual emergency action plans, and the inflow of one dam to another is taken care of in the emergency action plan. So if you look at the stages of the emergency action plan preparation and implementation, we divide into 4 parts. One is the preparation, which needs technical inputs, and that is the challenge in India and elsewhere. We don't have the technical capability. Dam break analysis, digital elevation model, inundation map. So here our advice is that in DEM, you don't need to go for a high resolution. SRTM is more than enough to go for a tier 1. And then when you have a more high resolution, you can replace it, right? And the second is the most important is the approval from the government. They are a little worried about the land pricing changes, panicking when people know about the dam break. These are the inundation area to be happening if a dam break analysis happens. The third is the stakeholder consultation. That is where you need to communicate to the stakeholder, telling them this is just a scenario. This will help you in early evacuations and all those stuff. That communication and endorsement from all the stakeholders is very important. And the fourth part is the implementation, the early warning system, the evacuation, the mock drill, and the updates. If you look at the table on the right, we try to map all the villages or all the settlement downstream, and you look at the time travel if a dam break breach happens, what are the depth, the velocity, and the evacuation routes. So all these details are being provided, and at present, this has been implemented in 223 dams, but as the Dam Safety Act passes by, it will be implemented across all 5,700 dams. That is it, Edwin, over to you, and I'll be more than happy to answer any question. And sorry for rushing up. The time is short, and a lot of things have to be there, so I rushed a little bit. Thank you for that.
Thank you, Mr. Singh, for your very interesting presentation. So, in conclusion, India have a gigantic number of dams and facing some issue like build, neglect, rebuild. This is scary, but this is interesting for discussion. And human resource issue, weak institution, and the last one is the lack of the financing. The way I see the DRIP 2, you already mentioned before, is pretty similar to those phase 2 in Indonesia. I mean, like identical twins. Also, Mr. Singh present the QA/QC works that been done in India, include the dam safety monitoring, revise OM manuals, inspection, real-time monitoring, communication system. This is very important, and especially facing the extreme weather condition. Maybe we can have some question in a Q&A session, but now, up next is Mr. Janus. Do you read me?
Yeah.
Mr. Janus will present about the in our session dam safety from space, and Mr. Janus is a professor in the Institute of Meteorology and Water Management in Warsaw and Wrocław University of Technology, a senior policy advisor at Odra Vistula Flood Management Project Coordination Unit, and also a director of strategy at the Wrocław Regional Development Agency. He is an expert in water management and regional policy, and also the author of more than 150 papers. Wow, that is huge. Publication and numerous professional evaluation in the domain of water management, environment engineering, application of mathematics, public finance, and regional policy. So, without a further ado, the floor is yours, Mr. Janus.
Thank you very much. I will share my can you hear my my screen?
Loud and clear, sir, but please, if you don't mind, to have it on a full screen mode.
Yes, now it's on the full screen mode.
Okay, perfect.
Perfect. So thank you very much for the introduction. I will present some kind of lesson learned in Poland. This is maybe less technological, more in the sense of innovative solution for flood protection, and it is connected with dry dams, the use of the dry dams. Here is the program of my presentation. Time is very short, so I will not go into details. So I will present Polish background, some kind of strategic approach where dry dams are very important and new solution. And I will present some strategic development like flood protection of big agglomeration in Poland, Wrocław agglomeration and Kraków agglomeration, which are based on combination of already existed water reservoir as a retention, and by adding dry dams and dry retention as a solution. So just you can see map of Europe with data describing flood risk and flood phenomena occurred after year 1980. As you can, and in the red there is a Poland on the map, and as you can see, this is one of the darkest areas. So the flooding is the main danger for Poland in case of catastrophic events. Poland practically has two big catchments. Vistula catchment, which is a little bit larger and less international because there is only some small Ukrainian part, and Odra river catchment, where this catchment is international, taking into account Czech Republic and Germany. And flooding events occurred frequently, and from time to time we have catastrophic flooding events, like it was 1997 in both Odra and Vistula basin. On the right side, you can see the map. It is the flooding is always coming from the mountains, from the south part, and the description of damages you can have described below. 2.5 billion euro damages, but in 1997 prices, so now it's probably twice big damages. And what is very important, especially in Europe, 54 lives was lost. Second big flooding event and catastrophic occurred in 2010 in Vistula basin, and again, as you can see, huge losses, including lives of people. So that is background why flood protection is very important in Poland. And one more photo. This is from my from my city. This is the main railway station, as you can see, 40% of the city, which is close to 1 million inhabitants, was under the water. And flood protection in Poland is nowadays based on European Union directive on floods, and you can have the basic components presented. So we always start with preliminary flood risk assessment, do flood hazard and flood risk mapping, and the most important is flood risk management plan for the catchments, and this is repeated in 6 years cycles, and now we are in the end of the second cycle. But very important is not only to plan, but to make implementation, and in the implementation, very important role played and still plays World Bank by initiated and co-financed project, and also important is EU involvement by co-financing flood protection project. This is the map of area exposed to flood hazards, and as you can see, they are concentrated on the main rivers, which is Vistula and Odra and some tributaries. But the logic of flood risk management plans in Poland is based on the of course some kind typical identification hotspots and analytical analysis. Then very important and there is priority for non-structural measures first. But immediately after, the most important is retention. And because retention is a reduction of risk without transfer downstream. And here, until for a long time, the most dominating solution were typical dams with wet reservoirs. And only in last 25-30 years, the issue to consider dry dams were taken into account. For a long time in Poland, flood protection was based on dikes and embankments, so it was some kind of local defense system, but it was practically always transfer of the risk downstream, and the European directive approach brought some kind catchment solution necessity, and this is why retention and dams, including dry dams as an innovative and new solution in old strategies, were important. And implementation, as you can see, of dry dams was mostly based on World Bank initiated and co-financed project. And even before EU flood directive, it was development and preparation of the first very huge dry dam, 185 million cubic meters only for flood protection. But then we have two World Bank projects. One is Odra River Basin, the second is for both basins. And as you can see in the first project, this one dry dam, the big one, was completed, and 4 another dams were prepared. And in still running project, we have 7 dry dams under construction or even already completed, and including 4 small dams in urban areas, and the project is financing preparation of 12 new dry dams for construction. The largest development is construction of Racibórz dry retention dam and reservoir, it is important because it is located on the border between Czech Republic, which is on the down side of the map, and it catches the export of flooding from Czech Republic, and is reducing the flood risk and for Polish part of the catchment. The construction, as you can see, total area is more than 26 square kilometers. The dikes, the embankment of the are practically 4 kilometers long, 10 meters high, and estimated cost, you can see two numbers. First number, it was when we started thinking, first estimation, and final costs were practically doubled to double the cost of the construction of the reservoir. Here is the main dam. As you can see behind the dam, there is a green area. It's a space. I will speak about the use of it when there is no flood. And here is for the first time use of this dry polder in October 2020. And the capacity which was used during this flooding event was 50%. So maybe the photo is suggesting that it is more, but absolutely the flooding event 2020 confirmed necessity and good solution, construction of this dry dam. This is the modeling, which is showing that practically for typical design floods, like 100-year floods, we could reduce the flood wave by half, from more than 4,200 cubic meters per second to 2,400 cubic meters per second, and which is substantially changing and reducing needs for building dikes downstream and creating quite reliable flood protection situation downstream in Polish cities along Odra River. It was interesting case because construction of this dry polder was connected with resettlement of two villages, and generally resettlement of people is a very difficult operation, but due to using World Bank procedures, now it is some kind of the showcase for international audience, even because people are very, very happy in the way in which it was done, despite that they lived there for many, many years and many generations. Other 4 new dams almost completed are in mountain area of Odra catchment, and in addition to the dam which I have already presented, it's additional 16.2 million cubic meters flood retention. And it helps not only on Odra River, but it helps for many towns. It helps for flood protection of many towns in Klocka Valley, which is upstream of Wrocław agglomeration. Something what is under development are dry polders in Vistula catchment. And as you can see in Stula catchment, the strategical area is Kraków, Kraków agglomeration, the 1 million inhabitants. It's a historical capital of Poland. And you can see on the map that there are wet reservoirs already present, but due to climate change and they are not deliver enough retention capacity to reduce risk of flooding for Kraków. So this is why there is a plan to locate 12 dry dams and to achieve additional 56 million cubic meter flood retention, which should reasonably and according to the expected regulation as expected to achieve flood protection in Kraków, especially that in Kraków we don't have any possibility for bypass solution or to increase height of dikes. Here is more detailed map, but probably is not so much visible. And concluding, because I'm running out of time, so I'm comparing dry retention and wet retention. You know, there are some advantages. In case of dry retention, practically the whole volume is only for flood protection can be used. So it's in that sense, there is a higher flood protection effectiveness comparing to wet retention reservoir. They are environmentally friendly. So practically they create much less resistance from environmental organizations, which are in Europe very strong and protested, and they are protesting against classical dams and wet reservoirs. Inside the polder can be used. So practically only during flooding events, there is a water inside. So outside of flooding events, which is vast majority of time, they can be, this area can be used for agriculture, but also for some economic activities, which can be moved out from the area in case of danger of floodings. In case of urban areas, there is a possibility to locate their recreation, park, and leisure spaces. So this is some kind of additional advantage of dry polders. And something what is also very important in case of, we especially did some kind of comparison of the Racibórz polder, the biggest one, the cost of the wet polder and the cost of the wet reservoir and the cost of the dry polder, and there are much cheaper unit construction costs in case of dry retention reservoirs. I think that I ran a little bit over time, but thank you very much for your attention. I'm ready to respond to questions.
Okay, thank you, Professor Zaleski, for the presentation. Professor Zaleski present the strategy and the management on dry dams for flood attenuation and flood protection in Poland. Include structural and non-structural measure, including building dry dams that is utilized only for flood protection. Maybe the question arises from the participant is how long that the dry dams allow to store water. Maybe we can save it into a quick Q&A session. Up next, we have Mr. Neil Andika. He is a lecturer of Magister Teknik and Pengelolaan Bencana Alam at Gadjah Mada University, and has involved in a policy brief discussion regarding the management of reservoir sedimentation at the Ministry of Public Works and Housing of Republic of Indonesia in 2021. Today, Mr. Neil Andika will present about the Indonesia river system that he developed. Mr. Neil?
Yes, can you hear my voice?
Loud and clear, Mr. Neil.
Yeah, I will try to share my presentation.
Okay, the screen is yours.
Okay, Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, ladies and gentlemen, or good morning for our distinguished speakers in Europe and another country. It is my honor to be able to speak in front of all of you. I recognize some of the new participants, then I realized that I'm actually their juniors. So I would like just to share some of our current experience and development about the IRIS DSS, which we developed to improve the dam operation and dam safety in Indonesia. I'm actually speaking on behalf of our team, including Fahri, Haifa, and one of my colleagues, which I met in Colorado State. Okay, the motivation of our development of the software is actually based on many things. If we dissect it into globally and locally, from the global perspective, we heard that the water hazard that occurs all over the world is occurring more frequently, particularly in the past 20 years. The effects comes from the most important thing is the climate change and the global warming, which later on increase the precipitation, particularly in wet season, and that also affect the number of recurring floods that happens, particularly in Indonesia. On the other hand, on the dry season, the precipitation is decreasing and cause a severe drought in Indonesia and also in other parts of the world, particularly in Africa. Those are from the climate effect, but if we look closer to another parameters such as population growth, land use change, and then water pollution and anything else, is the effect of water hazard is getting more dangerous, for humans, and also all the resources like flora and fauna. If you look at locally in Indonesia, particularly about the dams operations in Indonesia, based on our discussion and interview with some experts, either from the Ministry of Public Works, from Bappenas, and another institution, we heard that we desperately need a more sustainable reservoir operation to ensure the fulfillment of the water demands based on the water availability, to ensure the future water availability. And the second problem is that the reservoir operation in Indonesia until now, maybe or a couple years back, is reactionary. So we usually release water based on the water demand, but we did not predict for the future. I mean, like for a couple days ahead of us or a couple weeks ahead of us. So then we release water based on the demand from the consumer, either from the power generation or for the irrigation. And then the other things that due to the climate change and the increase of precipitation, we know that the flood discharge is getting bigger in terms of discharge, in terms of the peak flow, and the time occurrence is getting closer. So it's the peak is getting higher, but in the shorter time. Thus, we need a bigger flood storage, which also means that if we want to operate our dams we need to release the water maybe a couple days ahead before the flood come to our reservoir. Yeah, based on those backgrounds and problems, we thought that we need a more sophisticated reservoir operation. Particularly, we need to optimize how we operate the reservoir in terms of how we fulfill the water demands from the consumer, but also maintaining the safety of the dams. Yeah, so we thought that the most essential thing is a good rainfall prediction. We can say that rainfall prediction is the backbone of our models. And in terms of rainfall prediction, it means that we need a very good data, either from the ground station or from the satellites, because we often heard that garbage in, garbage out. Yeah, so if we don't have a good data, either for the in terms of precipitation data or the inflow data, then our analysis will be useless, or so to say. Yeah, the reservoir operation, we decided the requirements, or like how we want to develop is, first, it needs to be accurate. Our analysis have to be accurate, otherwise we cannot use it. And then have to be effective, have to be efficient, and we actually develop for Indonesia, thus needs to be appropriate for Indonesia. And then the fifth is it needs to be user friendly, so everyone can use it based on the limited knowledge about the software. Yeah, not about the hydrological analysis, but about the software. Need to be user friendly, and it has to be standardized. Yeah, based on the maybe module or the design criteria or the specification or another regulation in Indonesia. And it has to be integrated with the real-time data. It will be easier for us to make an analysis for the reservoir operation if it's integrated with the real-time data. Thus, we do not have to we don't have to be to get busy just to download data and then upload it and then check the quality. But if it's already integrated, it will make our works much easier. Thus, with those requirements, we try to develop what we call IRIS DSS. It's an Indonesian reverse simulation decision support system, which will focus on the reservoir operation or the reservoir water allocation in watershed area. The IRIS DSS basically is a software that will help the decision makers to operate their reservoir or in their watershed. For example, if water managers or water reservoir operations already try to predict that in the near future, in the next wet seasons, or in the next dry season, we're gonna need much water due to a very severe drought, then they will try to close the water intake and try to save as many as water as possible. So then we have enough active storage to accommodate the water demand in the future. Otherwise, or on the other hand, if in the next wet season or rainy season, we have a very heavy storm or heavy rainfall due to La Nina, then we will have to provide a sufficient flood storage by releasing water as much as possible. So we have enough or sufficient flood storage in our reservoir. That's the basic idea of the IRIS decision support system. That's the target of the IRIS. The first one is to the result or the output of the IRIS is to provide a reservoir operation pattern, or in Indonesia we call it RTOA, And the second thing is to optimize, or to have an optimization for irrigation pattern or water demand. Depends on the the purpose of our dam. Okay, our IRIS DSS actually have a couple of modules. Actually, we have 6 modules. We have and going to have 6 modules. The first one is the IRIS Calib or IRIS calibration, where its function is to calibrate the precipitation from the satellite data and compare it to the ground station, so we can have a more accurate data from the satellite. Next, after we calibrate the data, then we will calculate the inflow using the IRIS inflow. We can calculate the inflow based on the precipitation data, the satellite precipitation data that will come to our reservoir. Basically, it will calculate the historical inflow data for further analysis, and also try to predict the inflow that will happen in a couple of days or couple of weeks ahead of us. So we can prepare the reservoir operation based on the inflow, water availability that we have in our watershed. From the inflow, we will have the IRIS RESOP or reservoir operation, where in this module, we will analyze or try to build or operate the reservoir, particularly for a single reservoir, the IRIS RESOP. And then from here, it will getting interesting. First one, we're going to have the IRIS-Q, which it will optimize the reservoir operation for the single reservoir using the artificial intelligence, particularly the Q-learning. And then the other parts of the IRIS DSS is the IRIS flood, where we will try to, we are going to calculate the water level or the flooding that could happen in our watershed based on the inflow and all the reservoir operation in the watershed. And the last one is the IRIS cascade, where we will have a module to optimize the operation for the cascading dam. Okay, so actually the first 3 modules is already developed and will be available widely in our website in a couple of weeks, in the early next month. And for the another 3 modules will be available shortly after the others. Okay, maybe I will explain a little bit about each modules. So for the IRIS calibration, we know that the precipitation data can be obtained from 2 sources, from the ground station and from the satellite data. The ground station, usually the weakness is usually it's not accurate, or there's some error due to the shading or due to a malfunction of the station, and sometimes also have gaps if we do not have a good maintenance for the station. On the other hand, the satellite data, usually the resolution is not good enough, depends on the type of satellite that we use. Thus, there is usually some difference between the satellite data and the ground station. Therefore, we need to find the relationship between the ground station and the satellite data, which then we can use the IRIS Calib to find the bias corrector for the study area. Here's the user interface for the IRIS calibration. First, we will need to upload a zip file containing the location of the station and the data, the precipitation data. And then we will choose the quantile, which used for the calibration. And then after we push the run button, the iris calibration will generate the contour map, the bias corrector contour map as a result of the calibration. Yeah, for example, in this picture, you can see the bias corrector contour for the Java Island. We actually already calculate for the whole Indonesia based on available ground station data and the satellite data from the HOMF. For example, in Sukabumi, the color is kind of green, so it's I think it's around two, yeah, the bias corrector. While in the Solo or in Surakarta in here, it's around maybe 0.8, yeah, something around that for the bias corrector. So then that means that the data from the satellites need to be multiplied by the correction factor to have more accurate, or so it has the same value as the ground station precipitation data. Yeah, for the future calculation, we can download the bias corrector in a CSV format, so we will have it in a table and can be used easier, maybe in Excel or in some another spreadsheet. Okay, next is about the inflow. So after we know the calibration, we can calculate the inflow. Two things that we need in here is the shapefile DAS. For example, in here in the Kedung Ombo in Semarang, and also the GPM or the global precipitation measurement, which we have download and we store in our server. Then we calculate based on the Sacramento soil moisture accounting. Then we will get the flow, and it's already developed, and we have tried this to calculate for more than 200 reservoirs around Indonesia, and daily we only need about 5 to 8 hours to calculate all the inflow for our reservoir. Yeah, so for example, here at the top graph is the precipitation, and the orange graph is the inflow, yeah, to the Kedung Ombo reservoir. And the runtime can be a little bit more than 8 hours based on the busyness of the server. Yeah, if the server do a multitasking, so then the runtime of the iris info will take a longer time. And after that, we have iris reservoir operation. In this version, we focus on the irrigation, basically about the planting intensity in an irrigation area that's served by the reservoir, for example, in the Kedung Ombo. And then we can also determine the release routine, release regulation for the dam. Yeah, and the right picture is the flow chart. Yeah, there are a couple of input based on the inflow and then the correction factor. And then we also need to input some of irrigation characteristic, and it will calculate all of the reservoir routing and the target release, yeah, from the reservoir. Here's the user interface. At least we need about 9 input, including the time range, and then the ET node, the water demand, reservoir curve, and reservoir elevation regarding the characteristic of the reservoir, and then the inflow from the iris and also the local inflow. And then we also need to define the planting ratio, or the type of the jenis tanaman, ya, yang diperlukan di sana, and also the intensity, type of this vegetation that we have in the area, and also the intensity decision. For example, how many water that needs to release, or based on the area of the irrigation that need to be irrigated. And then in the right side is the picture of the result of the RTOA, including for the dry season or the dry year, a normal year, and also the wet year. So we already have all of those characteristics for our reservoir. And then this IRIS-Q is still underdeveloped. We will use the artificial intelligence and machine learning, particularly the Q-learning, to keep optimize the reservoir operation in the study area. For example, in here, if we want to optimize for the irrigation, then the objective to maximize the planting intensity based on the inflow data and using the artificial intelligence engine. And then we're going to have at least these 4 results from the IRIS-Q. Later, we're going to have for the hydropower, for the provision of drinking water and raw water, and also for the maintenance flow, which then have a different objective, and the user needs to define which water demand that needs to be prioritized. Yeah, so it depends on the function of the reservoir and which purpose that we will focus on or we will prioritize. And then we're also gonna have the flood and the cascade, basically like the recommendation on when and how much water then can be released from our reservoir, so that it will not cause flooding in the downstream area and also in the upstream area. And then the other part is about the cascade, which will try to optimize the water allocation for cascading dam. Of course, it will add more complexity because we will deal with more than one reservoir in the area. For example, in Indonesia, the well-known cascading dam is the Saguling, Cirata, and Jatiluhur, which have different purposes. Thus, we will have to each dam will have their own respective purposes. So then we have to accommodate all of that based on the water availability and connection between each dam. Okay, before I close my presentation, I would like to conclude that the IRIS DSS, we believe this is a good step for Indonesia to use this software, which has 6 modules: calibration, inflow, reservoir operation, Q, flood, and cascade. And we think that artificial intelligence need to be implemented and will take a huge part in our programming, particularly for the reservoir operation. And as the final output of the IRIS, that we will ensure the optimization of each part of water management in the scale of the reservoir or in a watershed area, including for the flood control, irrigation, provision of the raw water, and another purposes. And we hope that in the next year, all the people can use it. You just need to create an account and then you can use it right away as long as you have internet connection from anywhere and have another data for your study area. Okay, thank you very much. And that's all for my presentation. You can reach me in my email, and I will answer your question in the discussion session. Thank you very much.
Thank you very much, Mr. Andika, for your excellent presentation. So in conclusion, the IRIS is an data integrated development to analyze the reservoir operation patterns as the supply to address the optimization of irrigation pattern as the demand. It's also closely related to asset management, that we keep the outcome of our infrastructure, and also we have some predictive maintenance in the next future, and hopefully the development you now ongoing project, hopefully you can push forward into a deep learning utilization, sir. So we can have some very accurate analysis in terms of decision support system. But now, once again, the good data availability is the key once again. So in regarding of anything that requires some analysis. So the session is now is a Q&A session. Let me read some question that come from the participant. First of all, to Mr. Sriraj or Mr. Singh from Edward Flynn. Good presentation on DRIP and dam safety under your DRIP 2 and DRIP 3. Your Dharma, oh, we also have Dharma. Your Dharma system value will be very effective in managing risk and mitigation intervention. Mr. Flynn question arises in prioritizing these dams at risk and preparation of a project screening templates to justify the works. Mr. Singh, can you respond to Mr. Flynn's question?
Yeah, thanks, Edwin. Hi, Ed. I think Ed was one of our colleagues, and he has worked on the project, so he knows a lot more detail than many people. So we have a software called Dharma. Dharma is a database software which will be converted into an asset management plan, asset management tool. What we are trying to do is managing 5,700 dam investing. Any country will not have that money. So under DRIP 2, we have introduced a 3-tiered risk assessment framework. So the 3-tiered risk assessment framework will prioritize the dams for the investment of the existing financial as well as the technical manpower. So the risk assessment framework, Dharma, they will be all put together, where risk assessment will be happening using the DRIP, Dharma data, and Dharma will be converted into a asset management tool. Yeah.
Okay. The second question also from Mr. Flint. How valuable were the rapid risk assessment tools for advancing risk reduction activities in accelerating preparation for structural and non-structural measure or intervention in DRIP 2? Best regard from Flynn.
Again, the same question, right? Because 5,700 dam in DRIP 2, we are investing hardly $17 million. So the idea is to invest the money in the dam which is of the highest risk. So risk assessment has helped in identifying the dam with the highest risk. So for example, in a state like Gujarat, they have around about 156 dams. So they have prioritized 9 dams that is of the highest risk that will be taken up under DRIP. So the rapid risk assessment has helped in prioritizing dam for investment.
Okay, sir. As I mentioned before, Tara, we can have some like million question here. So we're gonna have to read the Q&A first, and then we go to the open mic, and then let the discussion flow directly. The next question is from Pak Ilham. Mr. Zaleski, thank you for a good presentation of dry dam. However, should the dry dam be provided with a regulator gate, or can it be just an opening with a certain width in the bottom of the dam in Poland? Maybe Mr. Professor Zaleski, if you can respond.
Yes, of course, this is a regular, typical dam for reservoir, as it was on my photo. So there is no special big difference between the dams of wet reservoir and dry polder.
Okay, Professor. Okay, Professor.
I think that was the core of the question.
Okay, next question is from Mr. Arif Firmansyah in Bahasa. Let me translate it for you. how the operation pattern in dry dam in Poland. Maybe you can have some brief explanation in operation pattern of dry dams in Poland.
I cannot hear you.
Oh, I'm sorry, sir.
Only when you start.
Okay, can I repeat? Yeah.
Yes, please.
There are question from Arif Firmansyah, Mr. Arif Firmansyah, questioning about how the operation pattern in dry dam in Poland, sir. Maybe you can have some brief explanation on the operation pattern of dry dams in Poland, because we also have dry dams here now in Indonesia.
No, practically we have two approaches to operation of dry dams. Some of them, especially the small one, practically they have very simple operational patterns, not complicated. Just they collect the water, and then when there is overflow, the water goes down and to the next place of retention. But in the big and middle size, there are similar operational manual like for wet reservoirs. So they are maybe not so complicated, but when you can operate the gate, practically we have manuals as for reservoirs, wet reservoirs.
Okay, thank you, Professor. And the next question is come from from Rahmayanti to Professor Koike. If you can still read me, Professor Koike. Rahmayanti asking about the procedure of early release, how to measure and how to calculate the early release procedure regarding to the hydrometeorological condition and prediction. If you don't mind, Professor.
Hello, can you hear me now?
Yeah, we can hear now.
Edwin?
Yes, sir.
Okay.
Yes, sir. Loud and clear. Okay.
Thank you. I'm sorry. Could you please repeat the question again? This is written in Indonesian language. I cannot read.
Okay. I'm sorry. I guess my signal is not too good. How to measure and how to calculate the early release procedure before the flood is coming, sir? Regarding to the hydrometeorological historical data and also prediction data, how we can elaborate those data into a good procedure in early release procedure.
Okay, this system calculate the current discharge, not only the river discharge but also soil moisture and evapotranspiration every time. Okay, not only during the event, but every hour we continue to calculate by using the observation. So that's why we understand the current situation, and as those values used as an initial condition, and we use predicted rainfall with quantified uncertainty. So then this time we use a 39-hour lead time prediction. So we can estimate 39-hour inflow, and we also have a current status of the reservoir. How much water can be stored in the reservoir during the next 39 hours? So that's why if the total inflow exceed the capacity of the reservoir, current capacity of the reservoir, we need to release in advance. Okay, and also if we can store all of the inflow into the reservoir, we can make a maximum use of the water for power generation. Not only the event, but every 6 hour the interval, we calculate we run this system. So that means this system can be used for making a maximum use of the water for power generation in the normal time. And if we predict the flood, we can shift from the normal time to the flood condition seamlessly. So in that way, we can estimate the flood. Of course, as I mentioned, flood forecasting includes uncertainty, but we identify the uncertainty by using the ensemble prediction. So that's why if we have enough capacity, we can use the low estimate prediction. And if we have almost full, we need to use a high prediction value. So in that way, we can make a maximum use of the capacity of the reservoir. Can you understand?
Okay, Professor. Maybe if Mrs. Rahma is not quite understand, maybe we can open some direct discussion. Maybe after this, this Q&A session, we're gonna have some direct discussion. It could be very interesting. Next question, yeah. Next question is come from Mr. Fahmi Hidayat from the PJT1 or the State-Owned Enterprises. Question to Dr. Andika: Has the DSS been applied in the river basin in Indonesia? If yes, where are the river basin and how about the result? Thank you, Mr. Andika, if you don't mind.
Okay, thank you very much, Pak Fahmi, for your question. Yes, because we are still in the, you can say, in the finishing touch for our software. We have tried to apply the software, particularly until the RESOP, particularly for the Kedung Ombo, as you can see or you can saw in the previous slides presentation, including the inflow and then the reservoir operation. Yeah, we already applied for the Kedung Ombo, but yeah, we will very pleased to be able to calibrate our model for another river basin and for another reservoir, because we understand that our model is still needs a lot of improvement, maybe regarding the user interface, and then what is the really parameter that can be improved, or the results, and then the graphics, and based on the user. And of course, after we launch it live in the website, we will try to do some survey for the user to understand what's the other things that we need to improve for our modules. But we will be very pleased to get your to answer your invitation to use it in the Berantas River Basin, Pak Fahmi. And yeah, we now just applied in the Kedung Ombo, and maybe we will try in a couple of days or in a couple of weeks for another river basin, such as in the Bili-Bili and another parts of Indonesia. Yeah.
Okay, thank you, Mr. Andika. Next question is from Pak Ilham. Oh, Pak Ilham again. Is it allowed, Pak Ilham, to question? Okay. Okay, it's allowed. Pak Neil, the objective function of the irrigation, is it only for irrigation or include in flood control in the downstream area, Mr. Andika?
Okay, Pak Ilham, mohon izin, memang the current software, the current version, because we actually, when we try to develop the software, we try from the small scale, and then we will scaling it up for the whole Indonesian reservoir. But for now, we, like I answer Pak Fahmi question, we develop it based on the case in the Kedung Ombo, which is thus the Kedung Ombo reservoir is the main purpose is for the irrigation. But then early this year, the Ministry of Public Works issued that all of the reservoir needs to be able to function as a flood control ya, kalau tidak salah. Tapi memang basically we develop the software for the irrigation, and then in the near future we will adding another water demand. Actually, for the hydropower, we already have the algorithm in our software as a flow through. We just need to add couple of calculation to know the energy production from the flow through in the intake and everything else. But basically right now we only have for the irrigation, but in the near future we will add another part like the flood control, basically for the dam safety, and also for the hydropower, and also the drinking water and raw water, Pak Ilham.
Okay, Pak Ilham, hopefully it will answer all your questions. Next session is a Q&A session is come to an end, and then next session maybe I will have Mbak Tara as some extra time. Mbak Tara, maybe until midnight Mbak Tara, we're gonna have some discussion.
Yes, I think the participants start to warm up before, maybe they're a little bit shy, so now they have more questions. So let's open up for the open mic session, Pak Edwin. Maybe some people can sing. No, I mean provide some remarks as well. Yeah. So would you like to lead the open mic session, or?
Of course.
Okay, sure. So
yeah, we have Pak Herian and Pak Talut Mbak Tara.
Yes, so Pak Ikwan, could you please kindly help to open the mic of maybe Pak Hevrian first? Yeah, Pak Edwin. Okay.
Yep, Mr. Hevrian, raise hand first. Please, Pak Hevrian.
Okay, Pak Hevrian, I think the IT team has opened the microphone for you, so you can unmute yourself to share your question.
Okay, maybe he has some technical issue. Maybe next to the next question, Mbak Tara, Pak Talut maybe.
Okay, so maybe Pak Talut, can we open the microphone for Pak Talut? Pak Ikwan, could you please assist? Boleh dibantu Pak Ikwan? Oke, sudah. Silakan Pak Talut.
Dengar Pak. Halo.
Jadi Bapak terdengar Bapak? Jadi.
Sore Pak.
Selamat sore Pak Talut.
Selamat sore Pak Edwin. Ini untuk penetapan di elevasi normal Pak yang di Batu Tegi itu kan sampai hari ini belum ada keputusan dari KKB Pak. Nah itu kami sampai hari ini sudah menaikkan elevasi di sebatas titik elevasi yang ada di bendungan, jadi nggak kami batasin lagi di 256 Pak. Nah untuk mendapatkan keputusan dari KKB itu ataupun dari bendungan, dari BTB itu apa yang harus kami lakukan gitu Pak? Nah itu yang sekarang lagi permasalahan di Batu Tegi Pak. Itu saja Pak Edwin.
Baik Pak Talut, saya coba jelaskan dalam bahasa Indonesia saja ya untuk yang ini ya. Jadi untuk para panelis, salah satu bendungan kita itu baru saja menyelesaikan pekerjaan untuk remedial works yaitu penanganan bocoran di galeri bendungan. Jadi ceritanya bendungan ini sudah lama sekali kita turunkan tinggi muka airnya sampai ke tingkat yang sudah 256 ya Pak ya. Nah setelah diperbaiki itu teman-teman menghadapi kendala belum mendapatkan izin untuk menaikkan ke tinggi muka air normal. Nah ini mohon pendapat dari para ahli dan panelis bagaimana trik ataupun apa saja yang harus kita amati dari bendungan sampai kita bisa berani naik kembali ke tinggi muka air normal. Mungkin ada yang bisa mewakili untuk menjawab.
Mas Edwin.
Yep.
Saya coba memberi pandangan aja ya.
Monggo Bapak.
Saya coba memberi pandangan. Jadi semua keputusan maksudnya KKB itu tidak berwenang untuk memutuskan, Mas. Ya, tadi Pak siapa? Pak Talut ya.
Iya, siapa?
KKB itu tidak berwenang untuk memutuskan. KKB itu hanya merekomendasikan. Jadi kalau kaitannya dengan ini, rekomendasi KKB-nya seperti apa? Yang memutuskan ya pengelola bendungannya. Dalam hal ini Kepala BBWS. Kalau terkait dengan perubahan desain, ya yang memutuskan Pak Menteri merubah persetujuan desain. Itu. Ya jadi jangan menunggu keputusan dari KKB nggak akan memutuskan itu. Saya kira itu Mas tambahan dari saya, Mas.
Baik Pak Dir, terima kasih banyak atas fatwa dan arahannya. Saya kira sudah jelas ya Pak Talut, dijelaskan oleh Pak Dirbenda.
Ya baik, terima kasih.
Terima kasih Pak Talut, terima kasih Pak Dir. Selamat sore. Berikutnya ada pertanyaan lagi atau Mbak Rahma tadi sudah menulis pertanyaan ke Pak Koike, tadi sudah dijawab. Apabila memang masih diperlukan diskusi, dipersilakan untuk open mic.
Minta dibantu teman-teman IT untuk membuka mikrofon Ibu Rahma Yanti. Terima kasih. Oh ya, untuk mikrofonnya sudah dibuka, Pak Edwin. Sekiranya mungkin beliau ingin menanggapi, saya persilahkan. Kalau tidak, mungkin bisa ada penanggap yang lain juga kami persilahkan.
Oke, mungkin lagi masih mencari ininya ya, partisipannya. Saya kira pertanyaan berikutnya untuk Pak Profesor Zaleski, tadi untuk yang operation dry dam, itu apakah benar exact similar dengan operation di wet dams? Jadi apa yang membedakan antara pola operasi dry dam dan wet dam? Yang berikutnya, pertanyaan kedua, ketika kita mendesain dry dam, apakah nanti dia itu diperbolehkan untuk menyimpan air dan berapa lama dia diperbolehkan untuk menyimpan air? Saya kira itu untuk memancing pertanyaan pada diskusi. Saya kira bisa ke Pak Zaleski, silakan.
Yeah, yes. Operation rules for dry polders are a little bit similar, but also a little bit different. Especially in the case of the outflow, practically you need to release the whole volume of the retention gathered during the flooding. And this is limited. This is limited because, for example, 185 million cubic meters to release to Odra River, it can take up to 2-3 weeks, and operation manual takes into account some basic limitations which allow safe release from the dry polder when flood event is behind us. Much shorter times for release are possible in case of much smaller dry polders in the mountains, where some event is flash flood rather, so it takes few hours, maybe one night or a day. They are in structure similar, but in case of some assumptions, they are absolutely different.
Oke, Profesor. Pertanyaan berikutnya, apabila setelah dibangun dry dam yang memang tidak berpintu, itu bagaimana mengoperasikannya? Apakah kita harus membangun pintunya? Atau bagaimana? Saya kira bisa di-translate ke Pak Saleski.
Yes, so in case of rather very small dry polders, this can be some kind of very simple gate or even overflow mechanism, but in that case it is reducing totally impossibility to control the use of the dry polder. So we try in Poland, we try to avoid uncontrolled polders where only overflow mechanism is controlling the retention inside the polder. But it happened, especially in case of urban micro polders, micro dry polders. There is very simple mechanism. It is even very difficult to call it gate.
Oke, terima kasih Profesor atas tanggapannya. Saya kira lanjut ya Mbak Tara untuk yang raise hand berikutnya. Mungkin satu penanya lagi yang live direct.
Baik, terima kasih. Bapak Ibu yang ingin bertanya atau menanggapi mungkin secara langsung boleh menyampaikan tanggapannya. Mungkin tanggapan bagaimana webinar ini secara overall, mungkin apakah bermanfaat ataukah mungkin ada inspirasi-inspirasi baru. Silahkan mungkin Pak Ilham, Pak Efrian, Pak Talut atau yang lain. Silahkan.
Saya Pak Irwin. Halo.
Jadi Bapak, monggo Bapak.
Iya, sebetulnya tadi pertanyaan saya ke Pak Zaliski itu, kalau seandainya dry dam itu nggak perlu regulator gate ya. Bikin saja opening terbuka, ini pada saat musim hujan, pelan-pelan air kan naik ya. Begitu inflow lebih besar dari outflow di opening, maka muka air akan naik terus sampai maksimum flood tanpa overtopping bendungannya. Nanti begitu inflow turun, maka muka air di dalam waduk juga akan turun sendirinya sesuai kapasitas opening itu. Jadi nggak perlu ada operator di situ. Hanya perhitungan hidrologi dan modelingnya harus pas sedemikian. Atau bendungannya yang kita buat dari bahan yang boleh overtop, bisa juga. Sehingga organisasi untuk mengoperate dam itu kita bisa minimize. Terima kasih Pak Edwin.
Terima kasih Pak Ilham. Saya lihat masih ada satu yang raise hand, Mbak Happy Triana. bisa di-allow ya untuk mic. Saya kira ini last question ya, Mbak Tara.
Oke, baik. Sudah di-allow, saya boleh langsung menanggapi.
Halo, selamat sore Pak Edwin.
Selamat sore.
Oh iya Pak, maaf tadi saya Rahma Pak, soalnya tadi ada kendala teknis di komputer saya, jadi saya pindah ke komputer Happy. Sebenarnya ini tadi pertanyaan yang menyambung di Profesor Koike sih Pak tentang masalah ensemble. Tadi kan sempat disinggung masalah tentang jadi untuk membuat prosedur e-learning itu kita harus berdasarkan ensemble. Nah, untuk membuat ensemble ini supaya bagus itu starting point-nya tuh kita mulai dari mana ya? Ataukah memang nanti kita bikin beberapa trial untuk membuat ensemble, ataukah ada semacam apa sih kayak batasan tersendiri gitu untuk ensemble itu sendiri? Kayak gitu sih paling Pak.
Okay, very good question. This ensemble prediction based on the GCM weather forecast, the operational system output we use. It is open by Japan Meteorological Agency and the US, the NCEP and the European the Center for the medium range forecast, ECMWF. These center provide the operational weather forecast. So based on that, the output, we make a downscaling, and also the couple with globally observed data set. And then we made the data simulation and downscaling, and we include perturbation and develop the ensemble the output. So that's why it depends on the mother model. JMA, Japan Meteorological Agency, US and European. So such a GCM output is a basis. If such a GCM cannot predict well, so our prediction also cannot work well. So that is a limitation. So for but as you may know, the current short-term, totally 7 days, the prediction accuracy is now has not been much improved. So that's why the making a downscaling and also the simulation by using the globally available data set, observed data set, we can get a better ensemble prediction than the past the age. So this is a current condition. We cannot confirm. So, but the DAM is a storage, not only the snapshot, not only the time series, but we can use the accumulated value by using the reservoir. So even a little bit different from the prediction, different from the accurate actual condition, by making a maximum use of that integration function of the reservoir, we can make a maximum use of such kind of the information. So that is the principle. Can you understand?
Sudah cukup jelas, Pak. Terima kasih.
Thank you.
Yeah, thank you.
Oke, dengan berakhirnya kejelasan dari Mbak Rahma, saya kira untuk sesi tanya jawab ini kita bisa akhiri ya, Mbak Tara. Jadi sekalian juga kita mengingatkan untuk pelatihan DEM Risk Score Assessment yang akan dilaksanakan besok. Sekalian mengingatkan juga untuk teman-teman PIU, besok akan dilakukan DEM Risk Score Assessment. Untuk itu kami akhiri dengan alhamdulillahirabbil alamin atas sesi keduanya. Terima kasih atas pertanyaan dan respon dari teman-teman, dan salam hormat kami terhadap para panelis dan para presenter, dan juga kepada Pak Dir Bendungan dan Danau yang sudah menemani kita terus dalam sesi kali ini. Saya kira terima kasih dan kembali ke Mbak Tara. Monggo Mbak Tara.
Baik, terima kasih banyak Pak Edwin Alexander atas sesi kedua yang telah dipandu dengan sangat menarik, dan juga kami ucapkan terima kasih kepada para distinguished speakers yang inspirasional dengan sharing pengalaman dan knowledge-nya yang dapat dibagi kepada kami, dan ternyata ada banyak pelajaran baik internasional maupun nasional yang dapat kita pelajari dan adopsi, harapannya untuk dapat kita lanjutkan ke depan untuk masa depan keamanan bendungan dan operasi bendungan di Indonesia. Baik, sekiranya pengetahuan dan pengalaman yang dibagikan dapat bermanfaat bagi teman-teman peserta yang mengikuti acara ini. Untuk menutup acara, kami akan ada closing remark dari Pak Direktur dan juga Bapak Isbran. Sebelum itu mungkin saya ingin menyampaikan sedikit housekeeping information bagi dua juara yang memenangkan kuis tadi di juara 2 dan juara 3. Mungkin dapat menginformasikan dan dapat berkontak kepada kami selaku panitia untuk dapat menginformasikan alamatnya supaya dapat menerima buku knowledge product yang telah kami sampaikan tadi. Mungkin tadi dengan Ibu Dian dan juga Dian Arif dan Dodi. Mungkin nanti Ibu Dian Arif dan Pak Dodi mungkin dapat berkomunikasi dengan kami melalui Q&A atau chat untuk dapat menerima hadiah buku dari sesi acara webinar kuis interaktif tadi. Baik, untuk menutup acara dan mempersingkat waktu, kami mempersilakan kepada Bapak Direktur Bina OP, yaitu Bapak Adenan Rashid, untuk memberikan closing remark-nya. Jika beliau masih hadir di sini. Mungkin sekiranya beliau hadir, dapat ikut menutup acara ini, tetapi nunggu mungkin dicek oleh panitia. Kami akan memberikan waktu kepada Bapak Isbran de Jong selaku Task Team Leader Program DEM Operational Improvement and Safety Project dan juga Lead Water Resource Management Specialist Bank Dunia untuk menyampaikan closing remark pada acara hari ini. Silakan waktu dan tempat kami persilakan, Pak Isbran.
Thank you, Tara, for excellent organization of this webinar. Thank you to all the presenters. I really enjoyed listening to each of the presentations. I learned a lot, very rich and very interesting material. And thanks to Bapenas and to the Ministry of Public Works, in particular to Pa Irfan and Pa Edwin for moderating this webinar so very well. Let me share a few thoughts with you that came up when I was listening to the presentations and listening to the discussion. In the first place, needless to say that dam safety is very important. And the government of Indonesia recognizes this very clearly. And the World Bank is very proud to work with the government of Indonesia on improving the dam safety of the dams in Indonesia. Management of dams and management of dam safety is becoming more and more complicated. Climate change means higher variability of weather-related events, in particular related to water. Dams are more and more used for multiple purposes, and that brings the obligation to balance the management in view of these different uses. And many of the dams are located now in cascades and need to be managed in a cascade and no longer on a standalone basis. So all of that leads to a significant complication of the management of dams, but also the management of dam safety. Remote sensing is a very important tool, as we have seen in many of the presentations, that can help us improve the management of the safety of dams in almost near a real-time basis. And we have been presented with a wide array of all these technologies. And again, thank you to the presenters for bringing this diverse experience up. I will not attempt to summarize it because the information was so rich. But I'd like to refer everybody to the materials that you can find online, and I encourage you to take another closer look at that. And many of these remote sensing technologies have proven to be very effective and have proven also to be very cost effective, very important for improving the safety of dams. But let me say two things that I think we all have to keep in mind. So why we recognize that remote sensing is a very important tool for improving dam safety, we have to be aware of the limitations. And some of these presentations have given very good indication of the limitations of these technologies. Remote sensing is not a panacea. It will not help us resolve all the problems in the world. And it has to be, and that's the second thing that I wanted to share, it has to be in addition to human action. It cannot replace human action. It has to be in complement of human action. The World Bank, as I mentioned, is proud to support the government of Indonesia in its efforts to modernize the water sector in general and the dam safety more in particular through financing of investments and by bringing in global knowledge. And this webinar is a nice example of how we can help bring in global knowledge that can help us better design investments in dam safety and better develop policies that can improve the safety of dams. We are, of course, interested in continue working with the government of Indonesia in the efforts to modernize the dam safety and the water sector in more general. And we look forward to continuing this dialogue, also dialogue in particular with Bappenas, that is, as Pa Irfan mentioned, Bappenas is preparing the midterm development plan and recognizing the importance of dam safety. So we look forward to continuing our dialogue, our discussion with Ministry of Public Works and with Bappenas to make sure that the dam safety is adequately reflected as a priority area in the midterm development plan. Thank you, everybody, again. Thank you also for the people who asked questions. I was very much encouraged to see how many people are still actively engaging and involved in this webinar. Thanks for that. And with that, let me hand back to Tara.
Thank you so much for your closing remark, by Isbran. We hope that this webinar could be a first start for a further, more interesting discussion with the government of Indonesia and the bank, and also other experts that can be useful, hopefully, for the safety of the dam in Indonesia. So I will continue speaking bahasa. Baik, Bapak Ibu, kami ucapkan terima kasih yang masih stay tune hingga akhir sore ini. Kami berterima kasih sekali karena sudah hampir 5 jam ini kita bersama, dan harapannya kita bisa mendengar sedikit lagi sepatah dua patah kata dari Bapak Direktur Pak Erlangga Marjono yang masih hadir hingga akhir hari ini untuk memberikan sedikit tanggapan, pesan, kesan mungkin atau closing remark terhadap webinar ini, Pak. Silakan. Terima kasih.
Terima kasih, Mbak Tara. Yang saya hormati Pak Isbran, yang saya hormati para panelis dan teman-teman dari World Bank, dari Bappenas, dari PUPR, Direktorat Bina OP, serta peserta semuanya. Pertama-tama kami sampaikan penghargaan dan terima kasih yang sebesar-besarnya atas penyelenggaraan dari webinar ini yang sangat menarik dan menambah wawasan dari para pengelola bendungan atau para engineer yang terlibat dalam pembangunan dan pengelolaan bendungan. Dan saya berharap ini bisa diselenggarakan dengan secara berkala gitu ya. Mungkin tidak sebanyak ini speakernya, tapi bisa berkala beberapa waktu lagi untuk 2 atau 3 speaker yang mungkin bisa lebih didalami lagi materi-materi tadi yang sudah disampaikan yang sangat menarik itu. Dan kami juga ingin nanti pesertanya bisa lebih banyak lagi. Ini alhamdulillah sudah 141, tapi saya berharap lebih banyak lagi sehingga nanti pengetahuan akan pengelolaan dan pembangunan bendungan ini bisa menjadi menjadi demam gitu ya di antara kita, karena memang kita sekarang sedang gencarnya membangun dan mengelola infrastruktur sumber daya air khususnya di bendungan. Mungkin itu aja Mbak Tara, Bapak dan Ibu sekalian, dan mohon maaf ini tadi Pak Dirjen juga tidak bisa hadir, jadi menugaskan saya untuk bisa menutup acara ini. Terima kasih, Pak.
Baik, terima kasih Pak Direktur Bendungan dan Danau, Pak Erlangga Marjono, yang telah memberikan penutup dari acara kita hari ini. Baik Bapak Ibu, kita telah tiba di penghujung acara. Semoga Bapak Ibu menikmati dan mendapatkan manfaat dari acara webinar ini. Semoga webinar ini dapat menjadi inspirasi untuk sharing knowledge dan experience ke depannya dalam upaya menjaga serta memajukan keamanan dan operasi bendungan-bendungan di Indonesia. Saya Tara Sinta, Water Resource Management Specialist dari Bank Dunia, mewakili tim panitia beserta Bappenas dan juga Kementerian PUPR, mengucapkan terima kasih atas kehadiran para peserta dan partisipasi aktif dari Bapak Ibu. Dengan demikian kami ucapkan terima kasih dan kami tutup webinar ini. Wassalamualaikum warahmatullahi wabarakatuh. Selamat sore.
Assalamualaikum
warahmatullahi wabarakatuh. Selamat sore, Mbak Tara.
Mbak Tara bisa nyanyi dulu, nyanyi penutupan.
Iya Pak Erlangga. Nanti ngantuk Pak kalau saya nyanyi.
Oke, makasih ya. Saya izin.
Terima kasih Pak Edwin, ya Pak.
Terima kasih Pak
Edwin.
Pak Ilham.
Ya, Mas Bran.
Thank you. Thanks everybody. Have a great evening. Bye-bye.
Ya, terima kasih.
Terima kasih Pak Nil.
Atur nuhun, sugeng sonten. Signing off.
Pamit Tara.
Ya, terima kasih Mbak Yuni.
Semua.
Ya Pak Edwin.
Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Mohon izin live Bapak Ibu. Terima kasih Mbak Tara.
Ya, makasih Mbak Yuni. Semoga sukses acara besok.
Ya, terima kasih. Jika memungkinkan bisa hadir juga ya Mbak Tara.
Oh iya, siap. Saya nanti akan hadir.
Terima kasih.
Terima kasih.